will be, okay, today's presentation will be about the impact of the El Niño phenomenon and the climate change on large and local scales of flow, looking at coupled rivers. So Marco, please go ahead and try to share your presentation.
Thank you, Michael, for the introduction. Can you hear me well?
Yep.
Okay, thank you. I will share now. Yes. I believe that you
Yeah, it's
are.
perfect. You can go on.
Thank you so much. Well, good morning, everyone. My name is Marco. Thank you so much, Michael, for the invitation, and also thank you to IAHR for the invitation too. So today, as Michael mentioned, I will be sharing my research about the impact from El Niño phenomenon and the climate variability at a large and local scale on the flows of the Pura and Rimac rivers. So in 2017, El Niño phenomenon impacted the Peruvian coast, causing flash floods, landslides, and damage to local infrastructure. Also, this image from this young brave woman who survived a flash flood was shown around the world, and everyone saw the news. Since then, last year in 2023, similar event occurred again. So there is a lack of disaster risk reduction management, and also a technology to measure and predict these events is urgently needed. So just to put in context, Peru is near these areas, is near the Niño 1+2 region here. Check this. And so the ENSO occurrence over the Eastern and Central Pacific coast has different impacts with respect to precipitation and flow region over the Central Andean and North Peruvian coast. As you can see, before any ENSO alert, the Rimac River, who is in your left side of the screen, were smooth and steady. Also, notice that the Rimac River is almost 30 meters wide, and the Pura River is almost 4 times wider with a low slope. So during ENSO occurrence over the Eastern Central Pacific, both of them increase very quickly in less than a week. The Rimac level was increasing 2 meters. Meanwhile, the Pura River, its level was increased by 10. You can see the difference between those two in GIFs in the upper left arrow. As you can see in this part, with the laser, you can see how the increase is very quickly in less than a week, and also notices that the river of Pura is almost with vegetation, and it's almost steady. If you can see in the background that the cars are moving, and then after a few days, you can see how much it has increased over a few days only. So sea surface temperature is changing, but you don't know how long it will take to impact the Peruvian coast. So in order to achieve the research of this or in order to achieve the goal of this research, we ask ourselves what technologies should be used to measure these short extreme events. So the main objectives was to update the relationship between the stream flow regime and the ENSO in the Pure and Rimac basins, and also in the subbasins by a correlational and statistical approach with a large-scale climate variability. And also another objective was to analyze these stream fluctuation events through LSPIB method, and this is able to measure flash flows through a proposed low-cost equipment, SNVL for its acronym in Spanish, with this non-intrusive approach. So, putting God in context, where is Peru located? Just near Chile, Ecuador, Colombia, in the Pacific coast. So we have two zones of study. The first one is Piura, who is divided in 5 subbasins, who is in the north part of Peru. And then we also study Lima in the Rimac River, who is part of the Peruvian capital. And also it has been divided in four basins, 4 subbasins. So if we took a look from the large scale, how do we study the ocean? The first step or the first approach was to study the climate variability that is collected from the NOAA's website. We obtained those data and generate our own streamflow indexes using local data and raster data from PISCO, from the National Meteorological Services in Peru. We also use a simple correlation as a second step, and then a running correlation using the HydroClim package in RStudio. And the final step was to analyze the results and a discussion of the correlation and flow rate figures. So as I mentioned before, we use different El Niño indexes such as ONI and Niño plus 1 and 2, 3.4, 3, Niño 4, and PDO also. We use so many indexes because we don't know how sensible it will be the SST response to specifically to Peru, who is this red dot. So obviously the Niño 1 plus and 2 has the stronger impact in the Peruvian coast, but we also need to know understand how the other indexes were behaving similar during extreme events. We also use some local and dynamic indexes that was developed from the IDP Institute in Peru. This tells you about how the Eastern pattern is behaving, also how the Central Pacific is behaving too. So the overall approach during this large-scale methodology was to obtain a correlation between an ENSO index and a series of runoffs from several basins. So here I wanted to estimate the relationship between the index and the runoff of the basin of interest using the running correlation coefficient, and to identify which basins over time show a stronger or direct or inverse relationship. To achieve this, I use 3 simple tools: RStudio, the HydroClim library, the code and index and the run database. You can update the data from the Niño indexes from the NOAA database. Then we, with young professionals, we developed and use the HydroClim package, who you can access to in the GitHub using the index core function. And in order to install, you just use this command of the deps to install GitHub, and you just the HydroClim package. Taking a look from the from these rivers and local creeks. We have used the LSPIB methodology, that it's a large-scale particle image velocimetry, to process the data obtained from videos in order to transform that information to cubic meters per second. We used the river software developed by Catalano and the University of Córdoba in Argentina. There we configure the frames and time selection for processing the data. Finally, we obtain the flow rate results, the surface velocity profile, and the discharge value for future interpretations. And this data has been compared with the ones obtained by the local authorities in Peru. So overall, what we wanted to obtain in the local scale was to estimate the flow value of streamflow videos of basins of interest by the means of image velocimetry, thanks to the river software. So far, we obtained the videos that are public and available through the National Service of Meteorology in Peru. We use the 2.5 version of the river software. It is open source too, and therefore we also use the river level data from Tsunami too. So if anyone is wondering how does this work, I can explain very briefly how did I did it. So the first step is to check for failures and delay errors before introducing the video to the software. This means that you have to check for a correct flow rate video instead of defective ones. You have to check for any delay on the videos, but you can introduce any video format, MP4, GIF, point MOV, anyone. So the first step is to validate the video manually. In this case, we have introduced 60-second videos, but the software only use at least 5 to 10 seconds in order to reduce computational cost. So after you have checked the video, if there are no any other mistakes, you check for the start and time of the analysis, also the color depth, RGB or grayscale, any adjustments of the video collection parameters that you can introduce to the software. In this case, the video I have introduced, it is telling me that it is a movie that has a duration of almost 40 seconds, and also it gives you the frame per second. So here you introduce how many seconds do you want to be analyzed, and you give them the image resolution, and you also introduce them that if it has any grayscale on it or any correct lens distortions. So after the image has been processed through the PIB lab application, you have to introduce another input that is 4 control points at least, because you have to tell the software how and where is your cross-section area. So in this case, I have introduced almost like 4 to 6 control points. It can be up to 8, but it will be depend on how wide is the cross-section area, and also it will depend on the camera angle that it is recorded at the time. So after you introduce those control points coordinates, you rectify, well, the software rectify the results, and then you obtain the discharge calculation. And if everything is according to you, you just need to introduce the bathymetry. And the software also need to know how depth is your cross-section area. And also that's why we work with the local authorities, because we need to know the water level, how is behaving hourly. And during this research, we have recorded 24 videos during the day. We have programmed the camera to record a 1 minute video every hour during the day. So overall, we have 24 videos with a duration of 60 seconds. So we have to process the videos manually with the software every hour. So, but overall, with the cross-section area and the bathymetry from um, the hydrological starting session, we don't need to calibrate the model every month or every season. We just need to introduce them the cross-section area once, the bathymetry once, and then we replicate the process with every video that is recorded during the period analysis. So this is the summary of how it would look like the methodology from the large to local scale. We have seen before how the indexes from El Niño was obtained from the sea surface temperature, and that was according to the large scale. And now we have video recording that gives you an idea of how El Niño phenomenon might be behaving to local scale. So how do we connect a large scale to the local scale? It is quite a challenge to connect different time and space relation, but we have connected the SST to also monthly recordings, and also we have used the videos to a monthly record too. So we have normalized the data of the monthly data of the SST to the El Niño region, or well, to every Niño region we have studied before. And also we have normalized the data of every flow rate discharge that has been calculated to the river software. So in order to obtain the flow rate, we have developed a system that is a velocity and level monitoring system in rivers that is called SMVN for its acronym in Spanish. So this is the response of the El Niño videos that we seen earlier in a presentation. All the gray area is what the authorities have shown or reported how the flow rate has behaved or has been calculated over the March. During the week in March, that has the rainy season, and the red dot has been the peak that has been calculated to this river software. So in the final picture, we have estimated that the Rimac stream flow has almost a peak of 42 cubic meters per second. Meanwhile, in Pura, we have estimated 10 times even higher this amount that has around 417 cubic meters per second. So this tells you two things, that the methods that use the local authorities tends to overestimate the flow, because they use the slope flow rate method. So they only use the bathymetry once, and then they use a formula, and from there they extrapolate the flow rate to every other season. To if, let's say, if they use an equipment like the ADCP to obtain the bathymetry in December, they just only obtain an equation to predict how the flow rate will behave, and that's it. So the difference between us is that we record hourly, and we have a much rapid or quick response of the flow rate discharge, so we can compare and give in real time data of how it's behaving, because this is only the first part of early stage flood warning system, because in Peru the peaks of the floods sometimes occurs, or well, the majority of the times occurs like in the morning, or when everybody's sleeping, at midnight, 3 a.m., 4 a.m. So there are no any other early stage of flood warning systems. This could be a potentially first part to build in a future study, a more accurate flood warning system. Because as you saw the first picture, there was only less than 5 days that the rivers reach their peaks. So for local authorities, it is almost kind of late to take a decision whether to evacuate a large scale of population or not. So this is how the system will look like. It has 3 main components that I didn't explain before. It has a camera surveillance. It could be also a GoPro, but if it has infrared light, it will be okay, because you can record during the night, and it is also hard to estimate that the flow rate discharge in those hours. The system, it is connected through an Ethernet cable, and the core module has a Raspberry and a battery to connect the video to send the information to the cloud. And that information is connected to a 3G network or Wi-Fi. And also we correct the water level sensor through a local device from a startup, from a Peruvian startup named Natec. And this has been funded by from Peruvian Research Center CITA and UTEC, and it is not so much expensive. It is almost less than $5,000 to implement this kind of stations that look like this. It also could have a solar panel, a battery, so it can be an independent system, and this allow us to record the data hourly, or it could be every 10 minutes too. Depends of the requirements of any research. It is you can program how frequent you want to record the video, but we are currently working in using an open source software to only give the video and then to obtain the water flow discharge instantly, because right now we only are studying or obtaining those flow rate discharge by hand, video by video, using this river software. But there are like a lot of initiatives like Open River Camp, who is trying to achieve this this tool by obtaining the data of the video and transforming to cubic meters per second. Is basically transforming pixels to cubic meters per second. So I would like to share my methodology summary that I have been doing in both of time and spatial scales. From the Pura remark basin, I have used a simple correlation between the SST and the flows to obtain a quick response, or just to do basic science. And in a monthly analysis, I have used a Mann-Kendall test to see if overall the time there is a tendency upward or downward tendency during these flows in Rimac and Pura. And in order to obtain the data daily or hourly in those basins, I have used LSPB. I have also divided these basins in 5 or 4 parts. I have also used Mann-Kendall study annually to understand a tendency. I have used the running correlation that it is telling me how those two variables of SST and the flow rates are behaving, because it is quite interesting to use the syntactic running correlation, because it improves a short-term frequency and a long-term low frequency patterns. For example, in this climate data, short-term patterns might show daily changes, while long-term trends could reveal seasonal or yearly effects. So that's why I have been using the running correlation indexes in this research. Also, the next one will be, and finally, I can show the results. I have analyzed all the ENSO types that have been occurring since the last 30 years, but here I have only showing the last decade, because the occurrence of El Niño is more frequently and intense every time. So as you can see, not all the El Niño scenarios are equivalent to a surplus scenario. That means that if the flows of the Pura is increasing, that will be that water is available, but it's not that local people cannot use it, because the water plants cannot treat the amount of sediments that they have after El Niño event. So I have also analyzed La Niña events, that it's the opposite. Sometimes here you can find that La Niña is equivalent to a deficit scenario in terms of water availability. That means that there is less water available for the people in Pura, and it is a quite interesting analysis in the last decade, because this random correlation figure for the Easter index shows that the upper, middle, lower, and lower areas can have a direct impact of El Niño, meaning that if it doesn't matter which ENSO type happens, it always will be occurring during all the points of the subbasins will be affected, from the highest part of the Andes to the lowest. The red dot is almost like 3 to 4,000 meters above sea level, and almost the blue dot is to less than 1,000 meters above sea level. So in this case, every part of the Piro River is affected directly. So I have used 3 to 5 time window move to obtain this result. The color means that there is a direct relationship during the flow rates with the ENSO occurrence of Pira. So there is a weaker signal of these two relationship on a 5 to 11 year time window. So most of the indexes have this similar behavior, but it is quite interesting because for Lima, the response to El Niño is quite totally different, because here the warmer scenarios for El Niño are not necessarily a subprocess scenario. Some weak or strong El Niño could represent a deficit in water availability, as shown in the last decade. And also here, there are some quick solutions, like these walls around the creek of the Rimac River in the highest area, in the red dot. So it can lower down the flow speed and the sediments that has this creek or gullies. It could be both of them. As you can see, there are some local living there, and it is very, very dangerous, because this is informal and illegal, but people is still building new houses, and it is quite dangerous because they don't respect these by living very near or very close to the edge of the river. And every year, or well, every attempt of El Niño occurring in Lima, the houses of people falls down to the river, and it is very tragic. But local authorities are working on that. But back to the science. This central index response tells you that it is an inverse relationship, as you can see. That means that an occurrence to the El Niño isotype, it will be a deficit in the water availability. And in the last decade of this time window, the upper part of Lima could have a very sensible response to El Niño occurrence, meaning that if this zone right here gets drier, all of the water of the following sections could be significantly affected, meaning that it could be water stress scenario, and it will be a huge issue for local authorities. So just to finish, I've been running a little bit, but what I have found so far, it's that the relationship between the flow rates and the ocean climate indices allowed to classify the surplus and deficit scenarios, and also the dynamic indices such as E and C from the Eastern and Central Pacific show a strong relationship for these basins compared to other operational indices. And I am not saying that the PDO or the ONIT were less efficient, but these specific indexes show a stronger relationship for for my research, and also the Pura River different altitudinal levels is always directly impacted by El Niño, whereas the flow response of the Rimac rivers is inversely affected by the sea index, with a stronger signal in the Santiago Elias basin. As I have shown previously, that is the upper red dot. Video analysis of the short string events through the LSPAB method allow peak flows measurements, but it is quite difficult to introduce ADCP during a flash flood. Nobody is ready to measure those events because it has a huge cost of the ADCP. You might probably know how much it costs to buy one, and also you have to go to the site to introduce the kind of equipment, and also you have to take in consideration the human resources that it takes. So it is quite very expensive to measure this through these flash flows through traditional methods. So that's why LSPIB could be a quite potential solution. Of course, it has its limitation. I haven't mentioned it yet. A huge limitation will be the how wide is the cross-section area. If it is longer than 60 meters wide, it will be quite challenging to adjust the angle of the camera to obtain the data from the LSPIB, because it is quite difficult to obtain or to correct the angle of the camera to transform the pixels to cubic meter per second. If you want to apply this to the Amazon, it will be quite challenging. You might need like 2 or 3 cameras or more to cover the extension of the Amazon River. But this LSPAV method, or this non-intrusive approach, allow us to understand better the impact of the floods and El Niño on the local climate scale. Finally, I would like to say thank you to all my research and university support, with a collaboration with local authorities and the British Academy, and to the project Fury of Rios, and the work with Peruvian startup Natec for developing the sensors and the technology and the support. And also thank you IAHR for the invitation. And you can contact me anytime for further questions or the methodology in this email. And thank you so much for your attention.
Thank you very much, Mark, for the nice presentation. We still have time for some questions, so if the audience has any question, you can raise it. You can write it down in the Q&A part. Waiting for questions from the audience. I do have a couple. Starting from the technology, you show that LSPID is pretty good to measure, flash floods, basically. And you said about limitation on the water, on the width of the channel, and well, the area that you can measure, actually. There are any other limitation in terms of, I don't know, suspended matter in the river, or bubbles, or?
Yes, that is also key. For example, here the vegetation is quite a problem to use the LSPIB, because it is almost static. And if we compare that to Rimac River, as we can see, the turbulence it is quite okay, and that allow us the tracking of the particle. But it becomes quite difficult, because the turbulence increases during this peak of flows, and it forms like a foam. This foam doesn't allow the tracking of the particles quite correctly, so you need to adjust or correct that. Also, in this case the color of the water is not a issue, but these strong waves that forms in the river can be difficult for the tracking of the particles. If it is like more smooth or calm flow, it could be easier to track. We have tried to use like wood, but it's like very tiny. I can't recall the name, but um, that allows us to improve the tracking of the particles in this area. Compared to Pura, the distance here it is quite challenging to obtain that area. As you might notice, the camera it is positioned quite to the left side, and the right part of the river it is not so much covered. But therefore, here is the challenge, right, to adjust these parameters. And the one I have been travel the most is the natural light. Recording during the night, it is quite a challenge because infrared light that does not mimics well natural light. So that is quite an issue too. So we are trying to correct that, but using one or more light bulbs or huge areas of light or like panels to that can bright a little bit more the flow, and those three might be the quite challenging: natural light, the camera angle, and the foam that forms due to high turbulence and sediments.
Thank you very much. You also addressed one of the questions coming out in the chat, so it's perfect.
Yeah.
Then, well, speaking on this, let's say this is a good technology to measure flash flood as a starting point of an early warning system. But then how do you see the integration of the information that you can get in the actual system? Because you say that the current approach is to use a more simple approach for early warning and with some delays in the implementation. So how do you see the implementation of this early warning system to the actual approach?
Currently, we are trying to study which areas could be potentially impacted from the flash floods, from high peaks of the flow increasing in this area. But it is quite an interesting topic, Michael, because we need to implement this solution in key areas. You cannot put these solutions, or it is quite harder to put these cameras in the lower areas of the river, because if you can see, these are controlled areas. The local authorities have built these walls to reduce or to control the flow discharge. But even though intense rains or precipitation can induce to floods, so it is also quite challenging, because if you install these solutions in the upper basin, the response to the lower basin, it will be much it will be slower. So our idea might be to monitor each each of these sub basins, because the majority of the people is living near the lower basins, specifically also from Fura and Lima, and this happens a lot of in Peru. The majority of the population is concentrated in the desert of Lima, of Peru, that is always near to the Pacific, to the Pacific coast, because all the upper basins are closer to the Andes. So we have a complex geography, and that makes a little bit harder to decide where to install uh, the system near the middle lower or to the upper. No, if you want to develop an early flash flood warning system, that will be a key. Key interesting topic. So far, we have only monitored like in real time a more hourly solution to this area that don't have that sometimes don't have the approach to obtain the data hourly. If we have the data hourly or daily, monthly, we can use that data to construct better models, numerical models. From that, we can go to get better infrastructure or design better infrastructure for these unique El Niño scenarios that happens specific that happens in Peru and attacks more in Piura and Lima. So I guess that will be our future approach for connecting these two, because it will be like a huge scale if you want to monitor all the basins in Peru. So, but we are starting by optimizing the calculation of the flow discharge, but not doing it manually instead of the river solver. So that will be that might be the approach that we will be taking in the near future.
I mean, I think it makes a lot of sense also because, as you say, this El Niño phenomenon will appear more frequently in the future. So we might have to connect those large scale and local scale even more in the next years.
Yeah, because you don't know when the next Niño will be. You might quite get an idea, but it is not always right. We have been with the Niño the last year, and also here in Peru we had with La Niña, and then we don't know if it will continue or it will be the Niño again. So we had quite to expect what will happen here in the Pacific coast, no, especially in the Niño 1+2 region.
Thank you. We are reaching the end of the session. Before closing, I would like to ask you for some consideration of how do you feel about the JFK paper competition, and what could be your message for the young professionals that are here listening to you.
Yes, for me it is quite interesting or a pleasure to share research, because in this presentation I've been trying to tell like a little story of how I've been conducted, how you can replicate these two for your area of interest. So for all the teams or colleagues who are competing, I will try to tell you that you might need to tell more like a storytelling. For this, I understand that the background science is very important, and also take in consideration that you are transmitting your research to a younger generation, and you're inspiring many young professionals to encourage to keep going with their researchers. and these spaces allow us to communicate them, and always try to contact everyone who is interested in your job, and all the ones who would like to replicate or to collaborate with you. This has been a huge collaboration for me by doing this, because this is my undergraduate thesis, and it has been a really great to share this among two PhD master colleagues. So I will encourage everyone who is finished an undergrad career to always try to look for these spaces to share, and always try to communicate the best way so everyone can get along with your presentation, and always keep going with wherever you want to go with your research. That's quite a potential message that I will say.
Great. Thank you very much, Marco, for the presentation and for this last message. As we are reaching the end, and then we will start the next session in around 5 minutes, I would like to ask all the attendees that have to speak in the hydroinformatics and global water security session to raise their hands so we can add them as panelists. And Marco, thank you again, and we will start back in 5 minutes. Thanks.
Thank you, Michael.
We have 2 minutes. So just a very quick note for all presenters. We will be sharing your posters, so you just need to focus on your talk. No problem with connection and poster sharing, hopefully. And we have 12 presentations. So probably if you stick to 5 minutes is the best, so that you allow everyone to have enough time to present. That's it from my side. Let's see if we have. I think you can speak if it's fast. For who raised its hand.
Yeah, hi.
Okay.
I made some changes in my poster, and there is a video in it. So I was wondering.
You sent it or not?
Yes, I have sent it before, but I
Okay.
want to send it right now if it is possible again.
Oh,
Or
you sent
share
it already
myself.
twice, right? Yes. Can you send it? Chang, can you please put your email or send him your email so that you receive it directly?
Okay.
Thank you. Thank you.
I think I need to start. So I would like to welcome everyone to this session on hydroinformatics and global water security. I would like to thank our chairs, David Vicente and Chang Ma, and also Chang for sharing the posters for every speaker. And without further ado, I leave the talk to the chair for moderating this session.
Okay, thank you, Ariana, for your presentation. My name is David Vicente. I'm a researcher at the International Center for Numerical Methods in Engineering, TIMNE. Welcome everybody to this session specific of hydroinformatics. So I think we are going to show very interesting presentations regarding numerical methods and different modeling frameworks. I would also like to introduce my my colleague. I don't know if it's here, Kian. Are you there, Kian Ma, from the China Institute of Water Resources and Hydropower Research?
Yes, I'm the. Can you hear
Hello,
me?
Kian. Yes, can you present yourself, please, very briefly?
Because I'm in my office, so I may have to open my mic.
Okay, we cannot hear very clear. Okay, but it doesn't matter. I think that we can start the presentations. The first participant is Laura Enriquez. She's going to present her study titled Using Symbolic Machine Learning as a Meta Model for Chlorine Decay in the Water Supply Network of Bogota. So, Laura?
Okay, good morning, everyone. I can't see my poster yet.
Can you see it now?
Yes. So
Okay.
I will start. So, well, good morning, everyone. My name is Laura Enriquez. I'm a PhD student at the Technical University of Bari in Italy. And today I will be talking about the use of a symbolic machine learning technique for chlorine decay modeling. And I will start with the motivation of my research. So chlorine is sparsely measured in the network in space and time, and hence other data-driven approaches have been considered for chlorine modeling, but also for optimization of chlorine dose as an alternative to traditional modeling techniques. So my case study is the water supply network Bogota that we can see in figure 1. And it is a highly complex network that provides water for over 10 million inhabitants. And the proposed approach is the evolutionary polynomial regression, or EPR, that is a symbolic machine learning method that generates mathematical expressions from data, and it selects the optimal inputs and also the exponents and related coefficients. So for the training data set, an advanced hydraulic and water quality analysis was generated with different chlorine and concentrations and first order decay coefficients. and two different strategies were used. So the first strategy was based on the work of Laucelli et al. 2024, in which a single model for all the nodes with water quality variables only as inputs. And the second strategy, in the second strategy, individual models were generated for each node with water quality variables and also hydraulic variables as inputs in different monitoring points. So in the results section for strategy number 1, we can see that a general R squared equal to 0.88 was achieved, which was a very high, value, a very good performance. However, some of the nodes didn't have a good performance, and for this reason, strategy 2 was proposed to improve the performance. So in table number 2, we can see the results for R squared number 1, for strategy number 1, and R squared number 2. And we can see it for 3 different nodes. And the performance greatly improves in strategy number 2 due to the inclusion of hydraulic variables together with water quality inputs. And we can also see in figure number 2, the chlorine concentrations at a particular node, which is node 140. In blue, we can see the simulated values. In red, the values from equation number 1, and in green, the values from equation number 2. And we can see that there is a lag between the simulated values and the values from equation number 1. And we can see that this lag is better described or modeled by including hydraulic variables that are relevant for the hydraulic dynamics of this particular node. And in table number 1, we can also see all of the expressions that were generated for each one of the nodes. And all these expressions include the exponential analytical solution of the first order model, but they also include correction terms with hydraulic variables such as the flow or the level of the tanks, and also water quality variables such as the decay coefficients. So as a conclusion, the chlorine decay phenomenon is both influenced by hydraulic and water quality variables, and they should both be considered in data-driven approaches. And also, the potential of this approach was demonstrated with this work, but further improvement is required to enhance the generalization capacity, since we can see that for approach number 2, the R squared are quite high, but they can still be improved. So thank you everyone for your attention, and let me know if you have any questions.
Thank you very much, Laura. Very interesting. I remember to all the participants, all the attenders, that you can ask your questions, your doubts in the Q&A chat, okay? And then in the coffee break period, we can share all your questions all together. So now it's time for the second presenter. He's Matteo Savino, and he's going to present his work titled 1D finite element scheme for the simulation of non-hydrostatic free surface flows. So it's your turn, Matteo.
Can you hear me?
Yes,
Okay.
perfectly.
So hello everyone, my name is Matteo Savino and I'm a third year PhD student at the University of Parma, Italy. And today I will present my work on a 1D finite element scheme for the simulation of non-hydrostatic free surface flow. So as we know, the shallow water equation are widely used for many applications like flow hazard mapping or designing hydraulic structure. However, the classical shallow water equation have some limitation when dealing with complex flow, where the non-hydrostatic effect play a crucial role in the motion. And then to address this limitation, we can relax while avoiding the high computational cost of 3D models. We can relax some of the shallow water assumption by using the so-called non-hydrostatic model. And in particular, among the all possible non-hydrostatic model, we decided to implement the vertically averaged and moment equation that introduce poor perturbation parameter that we can see in figure number 1, that relax some of the shallow water assumption by introducing a linear vertical distribution for the horizontal velocity and a nonlinear distribution for the vertical velocity and pressure profile. And then the resulting system of 8 unknown in 8 equation in 8 unknown is then solved by using the finite element scheme that we can see in the flowchart, where a streamlined upwind Petrov-Guerkin scheme is used to discretize the continuity, the x momentum, and the moment of x momentum equation, where an upwinding technique is used to enforce the stability of the scheme, while the remaining 5 equations are approximated using a classical Galerkin approach. And finally, the resulting nonlinear system is then linearized and solved by using an iterative Newton-Raphson iterative technique, where a residual vector together with a Jacobian matrix are evaluated at each iterative steps. So following this implementation, the numerical model has been validated against several experimental benchmarks. However,
Matteo.
due to the
Matteo, sorry to interrupt you, but I think that we cannot see your screen. Maybe there is only you are sharing the poster, but not the other tools. But I guess you are trying to show some kind of video.
No.
Oh, okay. If you focus on the poster, it would be better, I guess, for the rest of the
I was
people.
mentioning the flow chart in the poster on the left. Okay.
Okay.
So as I said, following the this implementation, the proposed model has been validated against some experimental benchmark. However, due to the lack of time, today we show only the steady flow over a symmetric bed form that we can see in figure number 2, where the numerical results are compared with the experimental observation represented by the dot points. And so, as I said in figure number 2, as we can see, the numerical results well agree with the observation data, both in terms of water depth on the left graph and the total bed pressure on the right. And moreover, the results highlight the strong non-hydrostatic behavior of this case test, because as we can see, the non-hydrostatic pressure that is represented by the parameter P1 is close to the 20% of the hydrostatic component. And this confirmed that this type of phenomena require the use of model that can relax the shallow water hypothesis. So to conclude, the proposed 1D finite element scheme based on the VAM equation overcome the limitation of the shallow water equation by introducing some nonlinear vertical distribution for the vertical velocity and pressure component. And the VAM system is solved within a single implicit time step and is found to be stable also for CFL number greater than 1. And as a future work, now I'm working on extending this 1D formulation to a 2D framework on horizontal plane. So thank you for the attention.
Thank you, Matteo. Very interesting. So let's move to the next presentation. Its presenter is Jadran Berbic, and he's going to present his work, Comparison of Tree and Ensemble Supervised Learning Chain Models for Prediction of Mean Monthly Flow. All yours.
Can you hear me?
Yes, perfectly.
Okay, great. Greetings to everyone. I am Jadran Berbic, and I will present you work called Comparison of Tree and Ensemble Supervised Learning Chain Models for Prediction of Mean Monthly Flow, made by me and my colleague and mentor Eva Ocvirk from the Faculty of Civil Engineering, University of Zagreb in Croatia. The objective of the work is to compare tree and ensemble models, totally 8 different supervised learning models, in order to predict mean monthly flow at hydrological station Vinalic at River Cetina in Croatia. Those 8 models are 3 models: decision tree regressor, extra trees regressor, random forest regressor, and ensemble models ADA boost regressor, bagging regressor, gradient boosting regressor, voting regressor, and stacking regressor. Hyperparameters of the model are optimized by already developed genetic algorithm on the calibration part of the data. To make this comparison easier, I will take attention to some terms. Bayes models are models used as Bayes learners for ensemble models, ADA boost, bagging regressor, and so on. Objective function is function used for calculation of fitness by genetic algorithm in order to tune hyperparameters of the model. Fitness is calculated as a coefficient of determination, r squared, and as a root mean squared error labeled as RMSE. Training and calibration are parts of dataset. Dataset is split chronologically in 3 parts: training, calibration, and verification. For any further information about area and models, please take a look at the previous referenced works related to the subject, because this is the continuation of previous works. And in this work, we wanted to see how models which were not used previously, how they react and how they predict. And also these models are compared with already existing stacking regressor model, which proved as the most accurate for this purpose in previous works. Therefore, I will take attention to the table 1, where results of genetic algorithm, that is fitness, is shown for 11 different models optimized in order to maximize coefficient of determination and in order to minimize root mean squared error, scaled root mean squared error. Beside the fitness, duration of genetic algorithm procedure is also shown in the table. And of course, performance of models is compared on the calibration part of the data. So the conclusions were next. Greatest accuracies were obtained by stacking regressor and then by bagging regressor. As you can see in the table, all of those are labeled by colors and rectangles. Also, the meaningful information is the duration of procedure, as bagging regressor performed little less accurately than stacking regressor. It is also worth it to say that the procedure for stacking regressor takes about 7 times longer. Both of those models are ensemble models and they use some learners. Optimized stacking regressor uses 2 dummy regressor, elastic net, and artificial neural network as base learners. Artificial neural network and elastic net were optimized in previous works, while those 2 dummy regressors have the its part in predicting low and high flow values, that is to let's say to create some sort of bias for low and high flows. Stacking regressor stacks.
Sorry, Jadran, you have to conclude, please, to keep in time.
Stacking regressor uses predictions from Bayes models and it stacks its prediction into final model, and as final model artificial neural network and also the elastic net was used, and artificial final model with artificial neural network provided most accurate results. And to conclude, tree and ensemble models provide high accuracies at the very early stage of genetic algorithm, as it can be seen on figures 1 and figures 2. Uh, uh, at the very early stage.
Jadran,
Yeah.
I'm really sorry, but we have a lot of presentations.
Okay.
So if there is something else, we can ask during the coffee break, okay?
Okay, if there will be any questions, I would be glad to
Yeah,
answer
sure.
them later.
Yes, sorry. I remind all the presenters, please, to keep in time. Yeah, we are very much presenters today, okay? So let's move to the next one. The presenter is Maxik, and she is going to present Enhanced LULC Mapping Tool for Change Detection and Temporal Analysis.
Good morning to everyone. So I'm Optic Shivasanjay. So my research is titled the Enhanced LULC Mapping Tool for Change Detection and Temporal Analysis. So as we all know, the land use and land cover change temporally significantly affects the hydrological cycle. So it is necessary to use a tool which is easier and simple to be used by researchers and policymakers for them to take in taking the change that has occurred over the years and understand why it is happening. So the current objective of the study was to develop such a simple tool. Although it was already developed by Chen et al. It was enhanced in the study to include temporal analysis and change dynamics. So the main enhancement in this tool was the addition of the chord diagram, which encapsulates the transition of the LULC classes throughout the years. For example, in this diagram, in figure number 1, you can see the chord diagram being presented of the Kansabati River Basin from 2019 to 2023. So as you can see here, each color represents a node, which is the land use class. So for example, the orange class has converted to the red class, which is the crops to trees. So the crops has been converted to trees, which has been represented through nodes. The thickness of the chord represents the magnitude of the change, and the from and to node represents from what it has changed to what. So, so this is an easy representation, although complex to understand it at first, but it visualizes the LULC transition that has been occurring. So we achieved a classification accuracy of 0.74 by training the random forest algorithm with 1,000 samples derived from the dynamic world and input data from the Landsat images. So although we had achieved a classification accuracy of 0.74, upon close observation of the chord diagram, we were able to see that the built-up area has been converted to cropland, which is like practically not realistically possible. So, on further analysis of the confusion matrix being generated from the machine learning algorithms, we were able to see that the trees and cropland had higher values closer to 1, which indicated higher precision of predicting these classes compared to the built-up, which had the values of 0.22 and 0.3 for crops and trees, which indicates that the built-up area is being predicted as either trees or crops. So we started doing this research by adding a chord diagram for the machine learning LULC map Python tool, so that it will be easy for us to understand the changes. But we were able to see that the classification itself has misclassified certain classes in a different manner. For the built-up area, for example, here. So although the chord diagram encapsulates the transition, this was able to magnify the misclassification being done in the machine learning algorithms. As a researchers, we all stop at the point of 74% of accuracy and move on with the usage of this data. So here, but the built-up area changes is a very crucial one which cannot be neglected. So the chord diagram, although it visualizes the transition of the LULC changes, it also magnifies the misclassification being done, which can be used for further studies. So apart from the addition of chord diagram, the Python tool was also enhanced by addition of the input options for adding shapefile and downloading the LULC map and including a line plot of the changes of each land use classes throughout the years. So although it has given a 0.7 for accuracy, we noted that this has produced some misclassification. So further moving on, the methodology should be fine-tuned by adding many post classification procedures to refine the machine learning classification process, and also use the latest deep learning machine learning algorithms for increasing the classification. So I think that is my presentation.
Thank you very much, Mathik. Very interesting. One question, Ariana, who is sharing the posters?
It's Chang. I think it's from online, and that's probably why. But
yeah,
I will just managing the me and her, I think.
Okay.
If Chang, if you can share the next one in the meantime, then we can. If it's still the same, I can do it. Just let me know.
Okay. So next presenter is Ahmed Emara.
Yes.
And is going to present his work titled Mapping of Abrasion Damages in Sediment Bypass Tunnels using Machine Learning. All yours.
Okay, thank you very much. Hello, everyone. My name is Ahmed Amara from DBRI, Kyoto University, Japan. And my research focus is about mapping of abrasion damage in sediment bypass tunnel using machine learning. At first, mitigation reservoir sedimentation can be achieved through sediment bypass tunnel, which diverts sediment flows around dams to downstream river reaches. These tunnels handle high velocity floods, but such velocity cause significant abrasion damage to this tunnel. So this damage can suspend operation for years with prediction challenges due to complex hydraulics and limited data. So this study employs XG-based machine learning techniques to develop 2D abrasion susceptibility model and 3D abrasion susceptibility depth model for the 4-kilometer long Kushibu SBT in Japan. And the main challenge is the abrasion in this SBT, critical issue impacting sediment bypass functionality during flood events, essentially for managing reservoir sedimentation. About the problem, the limitation of the existing model are limited to 0D assessment, providing only general abrasion rates, lacking for details, spatial mapping. So my study objectives is develop
wait a minute, Ahmed, sorry to interrupt you. Ariana, do you know why this kind of, yes, that window, I think that there are other windows that appear suddenly, I guess, isn't it? Okay, no problem.
It's the chat activating. It's please don't write Kyang, okay? Do not write her. She's sharing. Write me, okay? Thanks.
Okay, so please try to do as Ariana is suggesting, because if not, we are going to interrupt all the participants. Okay, so Ahmed, sorry for the interruption. Yes. You can continue.
No problem. So my study objective is to develop a predictive tool for abrasion in SBT, enhancing precision and accuracy in damage assessment, and through implementing machine learning techniques to improve existing quantitative abrasion models, focusing on spatial accuracy. So we have integrated hydraulic characteristics from 8 successive flood events with tunnel geometric factors for improved abrasion mapping. So as a result, the tool processes over 1 million data points, achieving high accuracy in predicting abrasion susceptibility This advancement enabled us to more effective maintenance strategy for future operations, and we have utilize this model to produce two types of model: 2D, if it is ground damage or not, and the 3D, if it is damaged. Okay, where what is the depth of damage? So this is how we have upgraded 0D existing models to 1D, 2D, and 3D. So as a conclusion, we have drawbacks. Existing models are quantitative based, providing a damage volume in bulk without any localized specifications. So we have machine learning implementation for the first time to have a region prediction considering the parameter associated with the flood event in hydraulics and geometric of the canal. And we have now opportunity to enhancing the existing quantitative models by transitions to a more predictive capability 1D, 2D, and 3D. And thank you for listening.
Thank you, Ahmed, very much. Very nice presentation. So let's continue with Mohammad Zainuddin. He's going to present Soil Param 2.0, a hydroformatics tool for near real-time hydroclimatic data access and forecasting.
Okay, thank you. Hello, everyone. My name is Mohammad Zainuddin from University of Laval, Canada. As you know, accurate monitoring of hydroclimatic variables is essential for effective water resources management, agricultural planning, and climate adaptation strategies. But traditional methods often face challenges like limited access to global datasets and the need for advanced technical expertise to acquire these sorts of data. Therefore, we developed an online application to address these gaps by using the Google Earth Engine platform to provide easy access to critical datasets and enable researchers to better understand, interpret, and even model with greater precision and efficacy. SoilParam 2.0 is built on the foundation of its prototype, SoilParam 1, by integrating a broader range of data sets and adding advanced functionalities, which I am going to present you today. I had prepared a video for the app, but unfortunately it is not possible to show it. So I continue to discuss the interface. These datasets are accessible by an interactive, user-friendly interface where users can access the major datasets like NASA's map for global soil moisture, soil temperature, with a 3D temporal resolution since 2015, the reanalysis ERA5 climate datasets from 1950 to the present time, and the FLDAS from 1982 onward. By entering the geographic coordinates and selecting time ranges, you can then visualize data as time series. You can see the description of the selected data set and find the necessary information like the collection period and resolutions at the bottom of the panel, the right panel on the app. And you can also find the link to the web page of the dataset on the Google Earth Engine. Finally, by clicking the submit button on the panel, the outputs can be downloaded in multiple formats like CSV or PNG. In the near future, we are planning to integrate the state space models to forecast a few steps ahead and give a good view of the dataset and future conditions. Right now, this part is under development, but it will be updated very soon. By scanning the QR code on the left, you can find the application online, and the right is our publications. Thank you so much.
Thank you very much, Mohamed. Now it's time for the next speaker, Diana Jimenez. She's going to present a study and characterization of sea and CN for watersheds in Cauca, Colombia, correlation and implementation.
Good morning, everyone. Thank you for this opportunity. I would like to share with you this study that we did along with my professor, Felipe Agreda, and me, Diana Jimenez, at the University of Cauca, Colombia. So we did an investigation that do the correlation between the runoff coefficient and the current number CM for 41 watersheds in Cauca, Colombia. So this study aimed not only to understand this relationship, but also to develop tools that simplify the runoff estimation and essential need for water risk management and resource planning, especially in the context of climate change. So the methodology that we follow was basically geographic information systems. So we download from our national hydrological institutions, soil maps, land cover maps, and we also download topographic characterization and morphology dams for doing the characterization of the slopes and the morphometric parameters. With all of the information, we could do determination of the C and the CN values following the soil conservation guidelines, and also the manuals and reports of engineering practice. With all of that, we got more than 400 polygons that we needed to simplify all of them for just 41 watersheds. So what we did was we did a script on Python called CNC calculator to unify those polygons. And also we wanted to do a validation with radar flights of that information that we got as you can see in the title of our study, we wanted to do a correlation because we did, and we found a strong linear relationship between the C and the CN number. And also we did an implementation with those radar flights, the comparison. So for the radar flights, we use a study in El Salado watershed, and study made by the municipality government of Paez, Cauca. So with those radar flights, we found that the CN value was 67.22, and the value that was estimated with our calculator was 57. This represented an 84% of the radar-based value. So there is, as you can see in the figure 1, is the map that we got for the CN values, as well for the CN, what we just put in there for space. So we also found out that the soil type C predominated in this area, in this study area, that represented almost 50% of the Department of Cauca. So this type C indicated that this area had a high runoff potential, sorry. Finally, for the conclusions, we can see that this methodology is really effective because we got good results, but it's so important to do the validation for accuracy with more precisely information as well as radar flights. And also the code that we developed on Python was really helpful to do all these characterization that we need. So thank you so much.
Thank you very much, Diana. Let's move to the next speaker. Is Nurul Rabita Daud. He's going to present the work titled Presence and Characterization of Microplastics in Drinking Water and Soft Drinks in Selangor, Malaysia. So,
thank you, David Vicente. Thank you, everybody. Thank you for the opportunity for me to present my research work here. Good evening, everyone from Malaysia. So this study was derived by a recent article published in April 2024, early this year, by Zhao in the journal Environmental Science and Technology Journal. So in his study, he found that Malaysia is #1 in consumed microplastic among 109 countries around the world. And Malaysia also listed as a top 10 inhale most of the microplastic, which the amount 494,000 microplastic per day per capita. Meanwhile, for the consumptions of the microplastic is around 502.3 milligram per microplastic daily per capita. So based on the numbers there, so it triggered us that we would like to know that how far it is compared to the local data. So because of that, we observe the presence of the microplastic in the tap water and also the bottled water that mostly consumed by the populations. In this study, we collect almost 2 liters of the water sample for each type of the water sample. And then we use the glass bottle in a way that we want to avoid the contaminations from the air and also from the other parts of the microplastic. And then we are using the filter system, using the filter papers, and then we dry the filter papers, and then we observe the presence of the microplastic and its categorizations under the microscope. So the sample were divided by 2, which we have the tap water and also the bottled water. For the tap water, we collected from the private residency, which we have 5 types of the residency, consists of the bungalow, condominium, apartments, and also the filtration system. And the second one, we have the public area, consists of the mosque, which is religious place, school, restaurant, hospital, and also the shopping mall. Meanwhile, for the bottled water, we divided into 2 types, which are the drinking water and also the soft drink. For the drinking water, as you can see in the figure there, so we have the figure number 1, yes. It consists of the spritzer, desa, cactus, avians, and Seamaster, which is the most common that we can find in the market. And then for the soft drink, so you can see the names, the brands are in the figure 2 on the poster, which we have the Coca-Cola, FNN, Sprite, Fanta, and Pepsi. So from all this, we collect 2 liters and then we process, and then the results come out. It shows to us that for the microplastics presence, we have 7.8 particles per liter in the private residency, and the public area, we have 7.6 particles per liter. And in the drinking bottles, we have much more numbers, which is double the numbers earlier. Drinking water, we have 12.6 particles per liter, and then most highest presence of the microplastic recorded in the soft drink, which is 20 pieces per liter of the microplastics presence in every liter of the soft drink. And from this, we also would like to know that how much it is can be for estimate daily intake by the individual. And then we calculate using the EDI, which is estimated daily intake. CR is the particle concentrations per liter, and then plus with the IR, rate of the ingestion, and then divided with the average of the body weight for the populations. And then we found out that the highest calculation is that 1.7 per particle per kg per day is coming from the soft drink, and meanwhile from the soft drink, from the drinking water is only 0.07. But however, it is still a large number that's surprisingly discovered through this study. And as a conclusion, it is important to assess the role of the drinking water in microplastic ingestions in people, even if there are various ways that the human are exposed to the microplastic. And with that, I end my presentations. Thank you, everyone.
Thank you very much, Nurul. Very nice work. So now the next presenter is Tianyu Suo. He's going to present his work titled Micropressure Promotes Endogenous Phosphorus Release in a Deep Reservoir by Favoring Microbial Phosphate Mineralization and Solubilization coupled with sulfate reduction. Quite a large title, but I guess very interesting. So it's your turn, Tianyu.
Oh, thank you. Hello, everyone. And I'm a PhD from Tianjin University in China, and thank you to the organizing committee for giving me this opportunity to share my research in the past year. I will be talking about how macro pressure promotes phosphorus release in deep reservoirs by supporting macro processes like phosphate mineralization and stabilization. China has many reservoirs, and unfortunately, most of them face phosphorus pollution. Famous examples like Taihu Lake, Chaohu Lake, and Dianchi Lake have suffered from severe phosphorus pollution for years. This not only damages to economics, but also threats to safety of drinking water for the nearby communities. Phosphorus from human activities such as domestic wastewater and agricultural runoff enters reservoirs and accelerates in sediments. Changes in hydrostatic pressure in these reservoirs can disturb the sediment-water interface, causing phosphorus to be released back to the water. To understand how hydrostatic pressure affects phosphorus release and the role of microbe in this process, we designed a hydrostatic pressure simulation experiment. We tested 4 pressure levels ranging from atmosphere to 1.7 MPa, simulation water depths from 0 to 70 meters. We measured key elements like iron, sulfur, and phosphorus at the sediment-water interface. We also analyzed different forms of phosphorus in sediment and conducted metagenomic sequencing to study microbe activity. Our results show that the increasing pressure triggered the transformations of organic phosphorus into unsuitable iron-bound phosphorus, leading to its release from the sediment. This happens because pressure stimulates microbial functions related to phosphorus mineralization and sulfate radiation. In short, hydrostatic pressure changes can significantly influence phosphorus cycling in reservoirs by affecting macro processes. And that's all my presentation. Thank you for listening.
Thank you very much for the presentation. Now it's the turn of Annie Jose, and it's going to present the work title, Optimize Stackling Ensemble for Groundwater Quality Prediction in Kanyakumari District, Tamil Nadu, India. So,
Greetings.
all yours, Annie.
Yes, I'm here. Can you hear me?
Yes, perfectly.
Okay. Good. Greetings, everyone. I am Annie Jose. I'm a PhD student from Center for Geotechnology, MS University, Tirunelveli, which is in India. I'm here to present my work, Optimize Stacking Ensemble for Groundwater Quality Prediction in Kanyakumari District, Tamil Nadu, India. My study area is the southernmost tip of India, which you can see in the figure 1. That study area map contains all the groundwater sampling locations and rainfall stations. I will directly go to the methodology. First, I have collected the 10 years of groundwater quality data and rainfall data. Then the data is processed. The outliers are removed based on the ion balance error, and then drinking water quality index is calculated. Then the data is prepared because whether we while we are incorporating the machine learning techniques, we cannot use strings, so they are label encoded. Then features are selected because it contains latitude, longitude, village name, and year, everything. It's about 20 input features, so I have to select select which is more suitable for the prediction, and features are selected, normalized. Then the 80% is taken for training and 20% is for testing. Then I have chosen k nearest neighbors, SVM, and logistic regression as base learners. Then they are stacked one above the other, and ANN is used as a meta learner. All of these are together made up prediction. After that, the performance is evaluated using the accuracy, precision, recall, and F1 score. Because I have used the classification analysis under supervised learning. Then in the results, you can see the relationship between the groundwater quality and the rainfall. You can see whenever there is an increase in the rainfall, there is the quality improves. 2000, nearly 2000, it shows excellent water. And when the trend goes down, where there is a downfall in the rainfall, then after that the confusion matrix is generated to see how accurately it predicts. Then we can see the prediction graph on the test data. After that, we can see the precision, recall, F1 score, and the overall the accuracy shows 97%, which is really feasible. Since it is a CSP data I have used, 97 is really feasible. We can use this according to my conclusion. It is really reliable. We can also improve. It is really customized to the study area. We can improve. It can also be used for other study areas, and we can study the various complex patterns under the data too. This method is cost effective and time saving, and it can be incorporated in real time too. Thank you.
Okay. Thank you, Annie. Next presenter is Elena Verina. She's going to present features of the water regime of high altitude rivers of the Altai Mountains, case study of the Katun River. So, Elena?
Yes, hello everyone. My research is devoted to studying the impact of climate change on the water regime of mountain rivers using modeling techniques. Modern climate change is causing significant glacier degradation, which affects the water regime of mountain regions. In this case, the runoff formation model ECOMAC was adapted for modeling river runoff in the high mountain basin of the Katun River in Altai Mountains. In order to evaluate the potential range of fluctuations in air temperature and precipitation for this region by the end of the century, the data from two global climate models was used. The period average temperatures and precipitation under three climate change scenarios for the time period from 2070 to 2099 were compared with the similar characteristics for the historical period from 1975 to 2004 to obtain estimates of possible changes for each scenario. Then these values that you can see in the table 1 were applied to modeling to evaluate the impact of climate change on river runoff using the delta change method. The results demonstrate that we have a direct correlation between the increase in annual runoff volume and the level of cruciality of the scenario. You can see it in the figure 1. The flow of the Katun River may change quite significantly, with estimates ranging from 6 to 11.5%. There is also an increasing trend for spring floods flow without the change in low water flow, which indicates an increase in intensity of melting of snow cover and glaciers. The experiments to assess the impact of area of glaciation on runoff were also conducted. The impact of glaciers is particularly noticeable in the basin of a small tributary of the Katun River called Kucherla. located in the high mountain part of the basin, where the proportion of glaciation is about 10%. And we can see that the total degradation of glaciation in this basin would result in an average annual river flow reduction of 31%. So to conclude, the Katun River is an important socioeconomic object, both as a source of water for the Altai region and as a tourist attraction. And the progressive degradation of glaciers in conjunction with climate change can lead to increase in summer runoff as a result of intensive melting at the early stage, and following by a decrease in runoff due to a reduction in glaciation area, as well as annual redistribution of river runoff, which may have a significant impact on the economy of the Altai region. Runoff modeling, which incorporates the characteristics of glaciation, demonstrate good results for high mountain basins and can be used for effective water resource management in the region. Thank you so much for attention.
Thank you very much, Elena. Very interesting. So let's go to the final speaker. Is the turn of Juan David Guerrero Delgado. He's going to present his work titled Optimization of Hydraulic Data Analysis and Processing through EPI Integration, Application in a Water Pipeline Project in UAE. So Juan
Hello?
David.
Is the microphone right?
Yes, we can listen to you perfect.
Okay, thank you. Well, I'm presenting more or less a case of study since it's a project that it's currently being designed in the office. My name is Juan David. I work at IDOM, Spain. And for a little more context about this is the optimization of well, the hydraulic data analysis and processes through API integration for a water pipeline in the United Arab Emirates. This is a 75-kilometer long pipeline. And even though we are in the whole parts of the design of this pipeline, I am working in the transient or in the water hammer analysis. So for this, we are using a software for hydraulic transient that is Wanda from Deltares. And what I will try to show here is how it can be possible to optimize all this data analysis and processing that it's the most of the time in a real project by using an API. And this is because usually the softwares that are used in the industry, like Water, Gems, Hammer, Mike, between others from the big enterprise, all of them works as a black box, and they usually you are limited to use what the user interface is giving to you. But this one, this software, Wanda, provides you an API to work through Python, and it helps a lot. And because usually the limit of how complicated the analysis can be, it's made by the owner's engineer. So for this project, we have 54 cases for the analysis of the water hammer. And this has been a really hard task, but with the automatization and the optimization that it can be done by having all the runs made in Python, having all the data processing that starts with the data extraction to data analysis to data processing. As you can see, I put two images. One of them is for an hydraulic surge that is presented when a valve is closed at the end of the pipeline, and the other is a sensitivity analysis that was made between different times of closure of a pipeline that was at the half of the a valve that was in the half of the pipeline. Basically, this reduced a lot the time that we were spending for each case, and also allow us to do a sensibility analysis, not only for example, that valve closure, but for pipeline roughness, for pump heads, for basically everything that the owner's engineer asks us to do. Also, it led us to a calibration in the state set that was then used for as the basis for the transient analysis. And we use the Python libraries for that analysis as NumPy, Pandas, and Matplotlib to plot the results and provide the reports that were required by the final client. Basically, just a little summary because I don't want to go through how the API works, but it allows to change every input, run the model from it, and just this part for being able to run the models automatically and programmatically instead of having the human factor that having to put run each model one by one, then extracting the results and maybe pass it through Excel to show them in meetings or everything. This has been a lot of process that was skipped since the API led us to have all those results directly exported and directly treated with this. So well, that was all. Thank you.
Thank you very much, Juan David. And thank you all the presenters, very nice presentations. And above all, thank you, you have keeping on time, all of you. Some of you even have lasted your presentations much less than the 5 minutes allowed. So now before the coffee break with introducing this discussion with all the questions that may arise related to these works, I would like to introduce a few minutes the committee, the Hydroinformatics Committee, which my colleague Kian and me are representing here in this session. So I'm going to share, Ariana, I don't know if it's better that I share my screen, I think.
If you want, yes, I think it makes your life easier.
Okay, perfect, Ariana. So can you see my screen? I guess so. Well, so as I told you, my colleague and me are representing the IAHR and IWA Joint Committee on Hydroinformatics. So, sorry. Oh, sorry. I don't know what's the problem.
It's the last slide. That's why. Go to the first slide. You are projecting the last one. That's why you get back.
Okay.
So you can go back words and it's not going to stop.
Oh.
Yes.
But no. Okay. Thank you, Ariana. So, very briefly, the scope of the committee, as you may guess, is related to the integration of IC, information, communication, and technologies with water science in the topics of hydraulics, hydrology, and water resource management. We have also a focus on a vision on to be very close to stakeholders in order to provide hydroinformatics solutions that could serve as decision support systems to politicians, to ecologists, to the social, to public means in general. And in this committee, we try to encapsulate expertise of different topics in user-friendly tools. As some of you have presented, very nice modeling frameworks that could be the start point to develop these decision support systems. And we have a multidisciplinary approach. So we try to have experts not only in the development of hydroinformatic systems and tools, but also in different topics such as physical, chemical, engineering, biologists. So this is a very nice opportunity to exchange knowledge between different disciplines. The members currently the committee is composed by 17 members from 10 different countries and 4 continents. The chair of the committee is Ibrahim Demir from the University of Iowa, and is still in the committee the past chair, the Professor Gabriele Freni from the University of Vienna, Core, Italy. And the rest of the members, most of us are mainly in the scope of in the academics and both on research centers or universities. So the working group activities, there are different work group activities that are mainly focused on 3 initiatives. First one, to propose, review state-of-the-art articles or special issues in Journal of Hydroinformatics or other journals, to the publication of books or monographs specifically on hydroinformatics, and the other main group activities, the organization of symposia, workshops, and conferences. And the leadership team committee, we assume 2 specific responsibilities. One is to give support to the Journal of Hydroinformatics, and then to organize the second one, to organize a biennial conference on this topic. So regarding the Journal of Hydroinformatics, if you don't know this journal, it has an impact factor of 2.2. And the purpose of the committee, as I mentioned, is to actively support the editors of this journal, proposing special issues and so on. And here in this journal, you can publish, you can present your works related to a wide range of topics related to hydraulic, hydrology, water resources management, or above all regarding process modeling frameworks. We can, as some of you have presented in this session, data science modeling frameworks based on machine learning or big data, digital twins are also very interesting to present here. But we can in this there are still space for traditional numerical simulations, and also to present studies regarding advanced tools like Internet of Things, virtual reality, and cloud computing drive innovation tools. And the second main thing that we are in charge from the committee, as I told you, is the organization of a biennial conference on hydroinformatics. This is the next one will be in the 20 and 26. As you can see here, it will be the 16th international conference, the 16th edition. So it's it has a large trajectory. These conferences. And this edition will be hosted in my country, in Spain, specifically in Zaragoza. It will be hosted by the Professor Pilar García Navarro from the University of Zaragoza. Zaragoza is a very nice city in Spain that is it's in the middle point from Barcelona and Madrid, and it has a very cultural, it's attractive to be visited. So I encourage all of you, if you have, as most of you are PhD students, if you think this could be a good conference to present your works, I encourage you to do that. You have enough time to finish your works. As here you can see at the left a potential calendar with the potential deadline for the abstract submission would be on September of last year. And as you can see at the right hand, the conference themes will cover different aspects of hydroinformatics, both related to different technologies and to different topics of hydraulics, hydrology, etc. So thank you for listening to me and the work that referring to my colleagues. I'm going now to stop sharing. Yes. Okay. And now it's time to discuss your works. as I told you, I think they have been very nice presentations. I think that in the Q&A chat, only one question have arisen, and it has also been answered, but I think it could be a good start point to resume this topic, because it was asked by Hasi, why R2? I think she was referring to the first work, and Laura has answered. But Laura, would you mind to share with the rest of the attendees your answer? Because I think the question is interesting, because we sometimes found works that only present the correlation coefficient, but why not presenting other metrics based on errors in your work? So Laura, are you there? Maybe Laura is not with us. Ariana? Okay.
Let me check.
So, okay, no problem. Anyway, I would like to arise this question, because I found it interesting that as I agree with Hasid that maybe other metrics are also valuable in order to evaluate the performance of the models. Well, anyway, this is your time, so please, I think you have been a little bit shy and you have not asked anything in the chat, but if you're interested in some topic of your colleagues, do you have any doubt, any question, any suggestion?
I'll break the ice. At Nurul, because I am also kind of into microplastics, but the other side. I'm just curious, which is the size range of what you like? Which size are we talking about? I do larger, like millimeter size. I guess you have much smaller. When you detected microplastics in soft drinks and like small amounts in tap water, you counted the particles. And did you know more or less which was the smallest size you can count, the dimension?
All right. Oh, so thank you, Arena, for your questions. So the smallest one, I couldn't recall right now, but we are using the filter paper that they have a size 11 micrometer. So anything that larger than that, so it's stranded at the filter paper, and then we observe under microscope. Yeah. So of course, yes, it's a very smaller sorry. So it's very smaller microplastics compared to the other ordinary microplastic study, because we also observe in the sediments and also in the water sample, like in the river and also in the Kelang River. You know, like everybody knows that Kelang River is most polluted river. So yeah. So, and then this one is just like this a simple study that triggered us from the recent paper that published in the early this year.
Thank you so much.
Thank you.
Thank you, Nurul. Is there any other question from the presenters? Would you like to complement your presentations with some additional information, or preferably, I would prefer if you have any doubt regarding other presentation of your colleagues? Please don't be shy. I'm pretty sure that most of you have doubts, and it may be very interesting to share with your hesitation with the rest of us. No? Okay, if not, I'm going to ask some questions to some of you. I found very interesting works here. I'm going to start with the works that I don't think they don't have mentioned any modeling framework and any hydroinformatic approach, but as this session focused on this, the works presented by our colleague Nurul and the other work presented by Tianyu, both of you have presented very nice works regarding collection of data. So my question is, do you expect, are you planning in your research to apply on following steps some kind of model of modeling framework, modeling approach in order to continue your studies?
Should I go first, or
Yes,
you want to go first?
yeah, Nurul.
Okay, thank you.
you.
Thank you for the questions. So it's really interesting one, because I'm really glad that my study have been placed under the hydroinformatic, because myself, I have a background in the hydroinformatic, which I study on the ocean's current. But again, because of the urge, that curiosity that we want to know detail on the microplastic, and then we simply conduct the study. And then further from the result just now, that we see how much of the microplastic have been discovered, especially from the bottled water, soft drink, but we couldn't close our eyes on the microplastics presence in the tap water. So looking at that tap water, I have further curiosity that we want to look into that from the water treatment plant. And then nowadays that they have the technology, because now some of the country implemented to filter the microplastic when they are distributing the water resources to the residential area. So the next further step is that we want to observe the simulations. What if we collect how much of the microplastics presence when they leave the water treatment plant, and then when they travel distributed throughout the pipeline to the residentials or perhaps the public areas, and then how much towards the end that it is collected. And there might be the contaminations or recontaminations throughout the distribution system on that one. To answer your question just now, yes, we do look up for the opportunity on the simulation model so that we could have a better understanding and then cross-check with the field data that we collected at the end of the distributions pipeline. But we are still considering what sort of the software programming that is suitable for this kind of the study. Yeah. So if there are any colleague here that they have like suggestions or recommendation to us, feel free to shout out to me. Thank you.
You need a multi-phase flow thing because you have the microplastics that are kind of suspended, and then you have the water. And good luck.
And there are so many factors that are going on.
It's a big one. That's a big one.
Yeah. But in terms of the concerns to the public health and also the water security, I think we have to begin from somewhere. Yeah. It might be not so perfect, but at least we have something. Right. So perhaps Tianyu would like to answer on your part on your study.
Yes, is there? Tianyu? No, maybe it's not with us. Okay, thank you very much for your answers. Very interesting work. I think we have some questions in the Q&A chat, so let's continue with that questions. Jesimu asked, thank you very much for your presentation. My question regarding, I think it's for the last presenter. My question regarding API model application, I appreciate if he could explain the applicability of model for other cases like modeling and optimizing of open channel hydraulics. I think it's a quite broad question, but Juan David, it was your presentation, I guess?
Yes. Well, basically,
the API can connect the components that are used in Wanda with programming. It is in, I think it's C, C#, and Python. That is the easier one. Basically, you can change everything that is an input in the model. That means that, for example, for the case that you are telling me, Wanda also models the channels, and you could change the lengths, the wall roughness, the width. And one thing that I really like about this software is that you have also control structures. So, for example, in the project that I'm right now, it's all a full pressurized pipe. But I am starting a different one in which I am also going to do the water hammer modeling. And in that one, the end of the pipeline ends up in an open channel that it's going to a reservoir. So basically, one of the things that we are thinking in modeling, because this concept design first stage of the project, we need to see, okay, which ones could be the worst cases in terms of higher and lower pressures. And since it's a concept, since it's not still defined the topography, the lengths, or everything, one thing that it could be done, and that it might be checked, but at the moment it's not clear at all. But because we are reaching to open channel, which how much is the influence of the length of that channel after the pipeline, and if increasing the channel and reducing a little the pipeline can make the pressure go up or go down. So basically everything that can be an input for everything in the model, starting from the roughness, from lengths, for even boundary conditions, you can change everything with the API and make an iterative procedure, sorry. And one thing that I enjoy is because I am implementing a library above that API, because there are use cases that are really frequent. So like getting the profiles, getting the water heights, getting the pressure along the system and everything. But one thing that I like that because of the fact that we have such a flexibility with the API, it's using algorithms, even simple ones like deception, to maybe optimize, okay, I need a certain pressure at the end of the pipeline, I need certain height at the reservoir after the channel. So I can iterate from, I don't know, from 0.01 the roughness in millimeters to 5 millimeters, and let's see which one will be the necessary to reach a reservoir that is 20 meters high. For example, this case, if you don't have an API, that is what I'm doing in also another project that it's being done in Hammer, you need to start putting the values, running the model, checking the results, and then maybe tabulating in some place so you can change the value again and then observe if it's changed again. So the applicability of this, I'm sorry if I maybe went out of the main question that was about the channels, but basically you can change and you can add algorithms to everything in the hydraulic modeling, and that has been a real time saver. And I think that's all. For this is an industry project, so there's no paper nor anything, but if there is any doubt or if anyone wants to know more information about not only the software or but the API as well, you can reach me.
Okay, thank you very much, Juan David. There's another question target to rule. So far, has there been any handling of microplastic pollution there? I guess in your case study, if any methods or technology have been used?
Thank you for IR and City Umum Council. So far, we've been working closely to the operator who manage for the water resource, water treatment plant in Selangor, Malaysia, Air Selangor. So far, they are looking for because we know that the concerns about the microplastic pollutions in our water resource, And then we have been closely looking for any technology that we want to add up to the water treatment plants to address the microplastic pollution issues here. But it's just a matter of the cost and time consuming when we are treating the water treatments plant. So so we are looking, still looking at the possibility to have it in the industrial operation parts, but for now, there's not really implemented at the treatments plant.
Okay, thank you.
Yeah, thank you.
Is there any other question? If not, I'm going to ask something to one of the presenters. I would like to ask Ahmed Emara is here. Is he still here?
Yes.
Okay. Thank you. I found very interesting your work and very nice your presentation. Congratulations. I would like to know some I usually work combining numerical methods with machine learning, but our approach, the most common approach is to generate synthetic data with numerical methods in order to train machine learning models. So if I'm not wrong in your work, I think that first you have you have developed the machine learning modeling with data, and then you have used the results of the machine learning modeling framework in order to train, to calibrate, I guess. I'm not sure. How do you use that data how you combine this data with your numerical methods regarding the these aberration models? So if you could explain a little bit.
Yeah, sure. Thank you for your questions. We have implement machine learning models, but at first we have implement information, regular information like water depths, water velocity, but we have conducted some initial methods like that used in existing model, because it's like we have high turbulence inside the tunnel. So until now, we don't have like general numerical based method or software to run. We, until now, inside the tunnel is like black box to us. High velocities exceeded, I think, 10 meters per second. So average, like not average, but most of software like cracked in these conditions. We had tried like smooth particle hydrodynamics, some part of my research, but I didn't succeed in that. So we have used like initial method to get water high and water velocity based on some cameras or calibration from this. And we have implemented this data, all hydraulic data from 8 events, and the tunnel geometrics from scanning this tunnel floor and make it all inside this model. And we have like some calibration based on we have compared observed with simulated result. We have like accuracy more than 80%. So at first step, it's not that.
Okay. Okay. Thank you. Thank you very much, Ahmed, for the clarification. Very interesting. Is there any other question? Ariana, have you put something related to?
It's related to the
It's
upcoming
related to the next.
session. Yes.
Okay.
Yes,
Okay. Thank
because
you.
we are I will repeat it in 2 minutes. Don't worry.
Okay. Yes, we have 2 minutes left to finish this session. So it's time if you have any other doubt, any other question. If not, okay, I think we can finish the session with a reflection about your works. First of all, congratulations to all of you. I think you are doing very nice works in your researches, and I would like to suggest to some of you and to always take into account the attendees of your presentations, because these kind of sessions are going to be attended by people from different topics. So take always this into account when presenting your results, your methodology, in order that most of the people could understand your works, okay? And also I told you that some of you have I'm very pleased that you have keep on time, all of you, but some of you have been very rushed, and only their presentations has last below 3 minutes, some of you. So I would also encourage for this is a first step from most of you, but be calm in your presentations. You are presenting nice works. You are doing so well. So be calm and take the time that the Congress allows you in order to present more clearly your results. Okay. And that's all from my side. Thank you, Ariana, for hosting this session. Thank you, all the presenters, and good luck with your research studies. And that's all. Thank you, all of you.
Thank you, David, and thank you, Chang. So before the next session starts, I please remind everyone who has to speak in the session flood risk management to raise your hands and accept the invitation as member of the panel, because that allows you to speak. And I think that's it. I pass it to the next host.
Thank you, Ariana. So I welcome you all to the flood risk management session. So this session will be hosted by myself, Manish Pandey, and my colleague Kwan Yu. He is here. And this session will be chaired by the Stephen Huan and Ali Pojagbar. So both are here, I think, Stefan and Ali. So now I'm inviting you. So over to you, Stefan.
Thank you very much. I hear you very well. Ali, are you in the room? I haven't seen you. No, if not, then maybe he will join a few minutes later. Yeah. But then then we will start the session, I would say. Thank you very much to the host for hosting the session today. Here he is. Hello.
Hello, everyone.
Hi, Ali.
Yeah, now I'm joining as a panelist, so I guess you can see me now.
Good, that is great. Welcome here to the session today. So we are the two chairs, maybe just a few words. My name is Stefan Haun. I'm the vice chair of the Flood Risk Management Technical Committee. I'm here, or in my usual business, I work for the University of Stuttgart at the moment. I'm the head of the laboratory there, and we are performing a lot of studies related to flood risk management, because we have here a huge development in the few years, and this also leads me more or less to the Flood Risk Management Committee. So we were funded in 2015. Just a few key things. We have 7 members, and we have 8 co-opted members. That means we are one of the large technical committees in IAHR. And I think this is really necessary because flood risk management is a topic, an ongoing topic. And we see from year to year that we have more and more severe flood events in the world, which we need to tackle. And this is more or less also a little bit the aim of our technical committee. So what we want to do is that we want to share in innovation because we have a huge development in our field. We would like to bring together practitioners, academics, and policymakers, because I think one group alone, one status group alone cannot handle this huge challenge in the future anymore. And what we are doing are developing documents and do other things so that we can promote flood risk management on the one hand side, and that we can support people who have problems with flood risk with floods all over the world. I think like this. So I could also, or I will also then share maybe a link in the chat about the white paper what we wrote recently about the role of hydraulic engineers in flood risk management, because many of us here in the room are hydraulic engineers, and in the past what we were doing was to develop flood protection measures, but meanwhile we are much further in this development. Maybe that's a little bit an introduction about the Flood Risk Management Committee. So join us if you want to participate or if you want to get updated at least, and also if you want to become active in the Flood Risk Management Technical Committee. We have elections next year. We have also free space in our members and co-opted members. So please feel free. Don't be shy when you think you're in a too early stage of your career. So every input is very welcome. And I would also like to hand over the word now to Ali. I talked a lot, maybe that he can introduce himself.
Thank you, Stefan. Hello, everyone. I'm also a senior researcher at Karlsruhe Institute of Technology. We are also involved in flood modeling, but usually we are focusing on the use of artificial intelligence and machine learning methodologies to predict flood susceptibility across different areas. Also, we are very focused on the consequences of the flood events that we have experienced here in Germany, even in July 2021. And you see, also recently in Valencia in Spain, we experienced a huge and extreme flooding event with, unfortunately, a great amount of casualties. So we are focusing to also investigate on the people behavior during flooding and after flooding, because it's also one of the great and important aspects that can increase the casualties during flooding. We have different modeling methodologies. We are focused on experimental, numerical, and also machine learning modeling approaches. Also, among the papers, I found some of them very interesting, and we are willing to hear and see their presentations. Thank you.
Thank you very much. These are very nice words. I also agree. I'm looking forward to the presentations, and I think we should not spend much more time in introducing ourselves. I think now it's time for the presentations, and I think for the very nice and exciting presentations. Just one very short question, Manish. I think it's 3 minutes presentation time per speaker.
No, 5 to 6.
5 to 6. This is even perfect, because in the discussion I heard 3 before, so I was a little bit shocked. In 5 minutes, I will give you a sign that you have 60 seconds left. I will raise my hand just to make that sure. We have 8 presentations. That means afterwards we have some time to discuss. I would keep it in this way also, that we make first the presentations in one row, and afterwards we will lead a discussion, because then it's much easier for all of us to get in touch and then to have a nice coffee chat. Good. If we all agree, yeah. If you all agree, then I would like to introduce the first speaker. It's Isa. I already have seen him here. He will talk today about the impact of climate variability on the Ottawa River flow depth using Bayesian analysis. Isa, the floor is yours.
Hello, everyone. I'm Isa Taj from Laval University. The objective of this presentation is to explore how climate variability impacts the Ottawa River's flow depth, with a focus on the role of precipitation and temperature. Using Bayesian analysis, we analyze 3 scenarios: high, medium, and low flow depths. Our study uses historical precipitation and temperature data to model flow depth scenarios. Bayesian analysis was chosen for its ability to incorporate uncertainty and identify probabilistic relationship between climate factors and river flow dynamics. This figure shows the results of our analysis. In the first scenario, high flow depths occur in 95% of cases with low precipitation. This indicates that other hydrological processes like snowmelt, groundwater inflow, or subsurface flow sustain in the high flow. Medium precipitation contributes only 5% and high precipitation is absent. This lack of sensitivity to high precipitation suggests the presence of buffering mechanisms such as wetlands or reservoir which help regulate flow and prevent sharp increases. The second scenario highlights medium flow depths, which is predominantly influenced by low precipitation, accounting for 91% of the cases. This demonstrates the system resilience where base flow, groundwater contribution, or delayed runoff help sustain medium flows. Medium precipitation accounts for only 8% and high precipitation is rare, further emphasizing the system's ability to stabilize a flow through natural features like floodplains or wetlands. Temperature also play a critical role. 41% for cold and 40% for hot condition contribute almost equally, reflecting a balance between snowpack accumulation and snow melt in colder condition and evapotranspiration in hotter conditions. Normal temperature contributes less than 20%, highlighting stability across extremes. These scenarios underscore the watershed's capacity to moderate flow through characteristics like soil permeability and water retention. The last scenario focuses on low flow depths, driven primarily by low precipitation observed in 90% of cases. Minimal rainfall leads to reduced surface runoff, with base flow sustaining the river. Medium precipitation occurs in 10% of cases, but it doesn't typically lead to higher flows, likely due to infiltration and storage. High precipitation has no influences as buffering mechanism prevent any direct impact. Temperature distribution show normal temperatures dominate more than 50%, while hot temperature about 40% further reduce flow through evapotranspiration. Also, cold temperatures play a minimal role with only 6% due to limited snowmelt under such a condition. To conclude, the Bayesian analysis reveals that precipitation is the primary driver of flow depth across all scenarios, while temperature plays a secondary role by modulating snowmelt and evapotranspiration. In the high flow scenario, low precipitation with more than 90% with a hot and normal temperature sustain flow through process like snowmelt and groundwater contribution. The medium flow scenario highlights a robust system with low precipitation, more than 90%, and balanced temperature extremes, maintaining moderate flow. And finally, low flow depths align with a low precipitation, about 90%, and normal temperature more than 50%, with hot condition contributing through evapotranspiration. This finding emphasizes the importance of accounting for both precipitation and temperature in river flow prediction and water reserves management. Understanding these dynamics is crucial for maintaining the resilience of Ottawa River system, particularly in the face of climate variability. Thank you for your attention.
Thank you very much. That was perfect in time, short before 5 minutes. Very interesting posters. Thank you very much for the contribution and for the insights on the Ottawa River and about temperature and precipitation. I would directly hand over to Ali now at this stage.
Okay, thank you, Stefan. We ask the questions now, or we go to the next speaker if you want.
I would go to the next speaker and would ask all the questions at the end.
Okay, great. Okay, the next presentation will be presented by Saeed Hashemikia, and they work on the performance of analytical models in predicting upstream to downstream water depth ratios in asymmetric open channel confluences with wide discordance. Okay, floor is for you, Saeed, please.
I think he presents yesterday, so maybe we should move to the next one.
Okay, the next one is Ahmed Durrani, and they will present risk-based design for urban flood risk reduction, a cost-benefit perspective.
Hello, everyone. So I'll begin the presentation. My name is Avais, and I am a first-year PhD student here in IUSS Pavia. I'm a part of like a national PhD program called PhD in Sustainable Development and Climate Change, where my specific PhD focuses on building urban resilience. So for flood specifically, currently we're working on green roofs as a flood risk mitigation measure for pluvial floods in urban region of Milan, because like we're working in collaboration with municipality of Milan. So for currently what we're doing is like we're working on green roof as a pluvial flood risk mitigation measure and trying to see its impact on the flood risk mitigation while considering the cost. So the overall objective of my research currently, it's like to develop an optimized model of implementing the measure. But this currently scenario, we're only talking about like from risk perspective. We have three components of risk. It's like exposure, vulnerability, and hazard. Currently, this part of the study, it will only focus on hazard and a part of exposure. Vulnerability is not yet included in it. It's a future work. So currently what we're doing is like we have this really good data set about green roofs in Milan, which has it's a prior work developed by another researcher. It has the potential green roofs in Milan. It has its latitudes, longitudes, the type of building, the total area where it can be implemented. So what we're doing is we're incorporating it with the urban flood risk mitigation model, which is a model developed by Stanford. The model basically works on the curve number method, which requires an input of land use, land cover, soil hydraulic group, and the rainfall intensity of a 24-hour period. So what we're basically doing over here is we got the land use, land cover data set from Copernicus for municipal area of Milan. We're basically changing the land use land cover. So basically land use land cover, when you get the data set, it has its own LU values for every specific site. So for example, if you're at an urban residential fabric, it will have its own LU code. So what we're basically doing is we're changing the land use land cover from urban fabric to urban residential fabric to urban green fabric. This is just an example. We have others as well, like schools, hospitals, residential buildings. So currently about the methodology, what we're basically doing is we're changing the land use land cover and implementing it in the curve number method and running it in the model. Like we've implemented the model in Python. So because we needed to do the iterations again and again for this scenario. So what we started doing was initially to run the random iterations to like just randomly select 5%, 10%, 15, 20, and then up to 100% of this green roof data set. Implement that into the land use land cover. So like technically changing the land use land cover into more urban green fabric, and then see the impact of this on the flood volume. So here in the results section below, we can see like this is a 10% and 20% area scenario. For area scenario, what we did was like to get the green roof data set and then sort it out by the area with largest to lowest. So which means like the areas with the largest areas will be substituted first into the land use land cover. So like to see the impact on the flood volume. After that, what we did now, the third iteration that we did was based on the flood water depth. So we ran a baseline scenario, and then based on that baseline scenario, we got the flood water depths at different sites. So we took the sites with the highest water depth and started comparing them to the green roof data sets. And when we found a similar point, we started changing those land use land cover sites to urban green fabrics. So based on that, we started getting the new results about reduced flood water depths. So if we see about the density curves over here, we saw like abrupt sudden decrease in the flood water depths in the water depth scenario, which is of course like something more logical. But like as we start to implement more and more scenarios, we can see the peak is going higher. So which means like more and more, a little bit background about the model. The model basically calculates the flood volume per pixel. So here we're talking about the pixel values. basically the pixel values, they're getting towards like shorter values, which means lower water depth. So as we start to implement the green roofs over there, the water depth starts to decrease and starts getting accumulated to a lower water depth value of about 25 centimeters to 20 centimeters. Whereas as we talk about like the area scenario or the random iteration, for the random iteration, the values were spread way more. So like it was about between 30 centimeter to 50 centimeter. But as we start to implement it, the curves more or less starts getting the same. So it's like getting towards like 25 centimeters of water depth, but still the number of values or like the population of values at 25 centimeters is lower compared to the water depth scenario. After doing this analysis, what we did was to implement the exposure file. So we already have the exposure file for the municipal area of Milan. So that has like the number of buildings, the floors and all. So we implemented those, combined this analysis with the exposure analysis. And when after overlaying these two files, we got the results for the number of buildings under flood water depth of more than 20 centimeters. So when comparing this, like we found out that almost 35 to 36% of the buildings were under more than 20 centimeters of water depth at area scenario and the water depth scenario. But for random iteration, the value was way higher. It was about like 37%. But when we start to implement the green roof flood risk mitigation measure, the volume starts to decrease. So now ultimately the values, they combine together at like 100% scenario, which is more like logical, because if we implement the whole of the measure, more or less the number of buildings should be the same. But now the problem over here is we can implement the 100% of the green roof buildings, but the total data set has an area of about like 19.6 kilometers squares, which can be implemented, but has like a high cost. So what we're trying to do is like using this as a background to have a comprehensive risk assessment where the reduced risk will be a primary benefit of the cost benefit analysis. So we already have the costs, but for the benefits, we'll be doing a comprehensive risk cost benefit analysis, and then just use this reduced risk as a primary benefit and find out the areas with the most optimal solutions. So in conclusion, the green roofs can significantly reduce flood risk, like it can have an impact on it, but to have like a comprehensive results, we need to do further cost benefit analysis of it. Thank you.
Thank you for the insights. Very interesting to see. I have a few questions for you, but they will come then later.
Okay, thank you.
Good, you're welcome. And I would say we switch to the next presentation. It's about the scouring process analysis of landslide dams, a case study of the Bake landslide. I hope I pronounced it correct. Dam break based on numerical modeling. And I have just to see if I have read everything, numerical model, and we see Himeng here as a presenter. The floor is yours.
He's not connected.
She's not in the room. You're not in the room? I don't know. Himeng?
She's not in the room. We can try later.
We can try later, then I would switch to the next one. Ali, do you want or should I?
No difference, please go ahead. Yeah.
Good. Then we go to delimitation of flood risk zones and tsunami currents in Acapulco, Mexico. Karina, are you in the room?
Hi, yes,
Here she is. The floor is yours.
thanks a lot. Good morning. Good morning from Mexico. Hi, everybody. Thanks a lot for this presentation. Well, this paper is about the limitation of flood risk zones and tsunami currents in Acapulco, Mexico. Well, first, I would see that historical seismological information in Mexico indicates that in Guerrero seismic gap, which extends for 150 kilometers along the Costa Grande for Papanoa, Acapulco to in Guerrero, Mexico, there have been no ruptures due to tectonic movements of from more than 110 years, which is why the possibility of a large magnitude earthquake remains latent. In this work, we prepare 288 hypothetical earthquakes that could occur in this area were defined and through numerical models of the propagation of the initial free surface of the tsunami, flow risk zones and currents were determined in the coastal area of Acapulco, Mexico. According to the results, it was estimated that in Acapulco Bay, the average arrival time of the maximum height of the tsunami is 30 minutes, which reaches a maximum distance of 800 meters. Well, in this paper, in this work, we make a numerical simulation model of 288 hypothetical earthquakes in Guerrero Gap with magnitudes from 70.5 to 8.9 were generated, and prescribing different magnitudes of the cosmic dislocation for different fault planes with lengths of 90 to 300 kilometers by 90 kilometers wide. The initial free surface of the tsunami was calculated using the software COMCODE, that is a Cornell multigrid coupled tsunamis, in which the cosmic vertical deformation for the seabed is obtained using the Mancina and the Smiley cosmic dislocation model. Synthetic tsunami propagation was performed with the flow model hydrodynamic for the MIC-21 software developed by the IAHR, using the initial surface numerical models of the propagation. In the 288 synthetic tsunami was performed, simulating a period of 10 hours from the generation of the earthquake. In the first figure, you can see initial free surface of the tsunami for the earthquake magnitude. The momentum is equal to 8.9 for the earthquake, and in the results, we estimate with numerical models for earthquake with magnitudes between 70.5 and 8.9, tsunami waves would arrive at the beaches surrounding Acapulco Bay with maximum heights of 28 meters. In this case, the arrival time of the maximum waves to the beaches near Acapulco Bay, it was estimated between 7 and 24 minutes after earthquake. The currents on the coastal front of the beaches surrounding the bay were estimated to be to 0.2 and 10 meters per second. The maximum flow distance that a tsunami would cover in Acapulco Bay is 17 meters for earthquakes of magnitude 70.5 and 850 meters for earthquakes to magnitude 8.9. In this work, we established that initial water level corresponds to the lower mean low tide level. However, if we have in tide high, we can estimate, or we can hope 0.59 meters is the increase. Okay, you can see in the second figure, the fluid surface in orange or in yellow, all depends on your computer, caused by a tsunami for an earthquake magnitude, the moment magnitude equal to 8.9. In conclusion, we can say that the current state scientific knowledge of tsunami is insufficient. There is still no theoretical model for fully satisfactory operational method that allows determining whether an earthquake is tsunamigenic or not, or what magnitude the tsunami generated will be. However, recent research and development of methodologies to estimate the height and arrival time of tsunami, though the cost allows us contribute to mitigation of their effects in coastal areas as prevention and self-protection measures. Thanks a lot. Thanks for your time.
Thank you very much, Karina, for the insights on the Acapulco beach. So we need to discuss then later what we are doing with tourism in the future if they see your results of your study.
Yes.
But that we will discuss later.
Yes. Thanks a lot.
Thank you.
Yeah, I think the next presentation will be about the hydrodynamic simulation of dam break flow using HECRAS, Raul Kandakatla. Sorry, I pronounce it. Yeah, the floor is yours. Yeah, please go ahead.
So thank you, sir. Firstly, my name is Rahul, sir, and I am from National Institute of Technology, Patna, from India, sir. The title of my study is Hydrodynamic Simulation of Dam Break Flow using HECRA, sir. India is a country which is predominantly depends on agriculture. The occurrence of rainfall is only for 3 monsoon months in India. Therefore, storing of available water sources through the dam is indispensable. In spite of these benefits of dam, a large devastation is caused due to dam failures. Failure in dam majorly occurs due to overtopping and piping. As per the dam incident database collected by the Association of State Dam Safety Officials, the dam failure incidents majorly arise due to overtopping failures in dam from 2010 to 2019. In the present study, the dam failure incidents are intended to be investigated by assuming the overtopping failure in the earthen dam. The selected study area is Hirakud Dam, which is situated across the river Mahanadi in the state of Orissa. In the earthen dam like Hirakud, mainly the failure occurs due to the erosive forces which leads to the breach formation. Development of dam break prediction model requires 5 breach parameters such as breach bottom elevation, breach bottom width, breach formation time, water surface elevation at the time of breach, and side slope of breach, as well as the mode of failure. For an earthen dam like Hirakud, breach formed in the shape of trapezoid. Breaching time for earthen dam ranges from 6 minutes to 3 hours. The values of side slope for breach ranges from 0.25 to 2.0 for earthen dam. From the analysis of 142 dam breaches data, it has been found that the mean breach width in earthen dams is 2 to 3 times of dam height. The modified normalized difference water index, which is MNDWI, plays a key role in identifying the water features by considering the built-up features in Google Earth Engine software. Further, by using QGIS software, a shapefile is created which represents the real-world opposite. It means it represents the boundary. Then using the Earth Explorer USGS, DM model is extracted, which is used for the study. It means to analyze the path of the flood. This digital elevation model plays a very vital role. In HECRAS, normally the inflow hydrograph is used as an upstream boundary for an hydrodynamic study. For the downstream study, we have used a frictional slope. This all the input parameters of breach and the frictional slope we have taken from the literature studies. Moreover, the study deals with analyzing the areas affected in the downstream of Hirakud Dam during the breach formation using the HECRA software. By thorough analysis of dam failure, there is a possibility of departing the people in the downstream. After the simulation, different output parameters such as longitudinal surface profile plot, cross-sectional plots obtained from the HECRA software. The flow profile at downstream before and during the dam break will be found in these figures. If we see this figure, before the dam break and during the dam break, we can see the difference in the depth of the water. And here we have taken one of the cross section in the downstream to see the difference before the dam break and during the dam break. So by this we concluded like as compared with before dam break, the velocity plot or the depth of the flow or water surface elevation, everything is increasing, enhancing its magnitude during the dam break. Thank you so much, sir, for giving this opportunity.
Thank you very much for the insights of your study. I would switch to the next presenter directly, because now we are going to the ephemeral basin, identifying runoff generation area for flood control in the ephemeral basin. Piero, are you in the room?
Yes, I'm here. Thank you so much.
Good. Floor is yours.
Can you hear me?
Very well.
Okay, thank you so much. So hello everyone. Today I'm going to present my research called Identifying Runoff Generation Areas for Flood Control in a Ephemeral Basin. I'm Piero Zulueta. Well, in recent years, the Peruvian dry coast basin has been seeing the reactivation of the ephemeral rivers due to extreme events such as El Niño phenomenon and Cyclone Yaku in 2024, leaving damage in the lower part of the basin. In those basins, it is hard to measure due to limited information and irregular extreme precipitation patterns. So this study focuses on identifying runoff generation areas within a ephemeral river in the south of Lima, with the goal of enhancing flood mitigation strategies. So for the methods, as we can see in the figure 1, as a first step, we introduce meteorological data as first input, precipitation and temperature. These variables were entered from two sources, precipitation from in situ data, which is field data, and temperature from meteorological data by product PISCO from Tsunami. The period of this study is to 1981 to 2016. So these variables had to be corrected and completed by interpolation and altitudinal grading corrections. And then we calculate the potential evapotranspiration by Orin method that is recommended for estimating runoff. Then after the precipitation and evapotranspiration were processed, we obtained the values of these variables throughout the basin in raster format for the period of 1981 to 2016. Now we got the composite infiltration coefficient in raster format. The slope infiltration coefficient was obtained from topographic data, SRTM. Vegetation infiltration coefficient was obtained from global land cover. Soil infiltration coefficient, KS, was obtained from soil grids. And the last coefficient, that crop coefficient for natural land cover, were obtained from Copernicus land cover. These coefficients were introduced using the runoff equation. These coefficients were introduced using the runoff equation using modified RAS by Juncker in 2005. Once the model has been processed, we obtain the runoff raster in two scenarios, annual average and just March. Finally, the results has been analyzed, being March the chosen month for the runoff generation areas for flood control. As we can see in the figure 1, the results reveals that runoff generation zones are located mostly in upper part of the basin with more of 20 millimeters per month, and also interestingly in the middle upper basin with a contribution to 5 to 10 millimeters per month. So this mapping facilitates the identification of optimal location for mitigation measures, such as the construction of hydraulic infrastructure or nature-based solutions by targeting areas contributing to the runoff generation and flooding hazards. This research also provides a framework for applying these methods to similar arid watersheds in Peru and other regions facing increasing flood risk due to climate variability. I also like to add that we installed a remote sensor. We installed a remote sensing product that was implemented in a strategical location for monitoring how the flow evolves over time, as long as the flow reactivates through these extreme events. So the conclusion for this research is that this proposed methodology allows to identify regions related to flood generation areas. And this area that we've seen in the figure 1 accounts for 13% of total basin area and is located mainly in the upstream, but also in the middle upper basin. For an engaged basin with social issues which do not allow to flow more than some limits, this methodology is encouraging as a first approach of runoff generation areas based on climatological forcings and land characterization. So further works can include the hyper-concentrated flow routing as very high sediment loads generated. So thank you so much. I'm ready to answer your questions.
Good. Thank you very much. We have 2 more presentations and then we will start the discussion part.
Okay, in the next presentation, Ramtin Sabeti will talk about reconstructing historical flood events using Monte Carlo approach and automated HECRES 2D. Please go ahead, Ramtin.
Thanks very much, Ali. So I'm a research associate at the University of Bath in the UK. So my research is focused on reconstruction of the historical events. So historical events in this title means those events that we don't have actually the data was measured, or maybe partially measured. So we are focused on the event of 1968. And the problem was that that event, basically the devices that they had at the time in southwest of the UK couldn't measure the peak of the hydrograph. I mean, the reason was the flood was very severe than they expected, and the measuring devices couldn't measure the peak. It was overwhelmed. So we're trying to come up with some sort of a innovative solution to find that peak. So the solution is to going backward like a reverse engineering process. So we found some flood marks in the area that people, kept it very well just after the event. The flood marks are those, for example, in the buildings, they had some plaque that they kept the flood level, the maximum flood level just after the event. Or some of the pictures also could be, we use some of the pictures from the event as well. So we put all the flood marks together, and then we made this decision that we need to, we need to basically address the high uncertainty. So because of that, we use the Monte Carlo simulations, Monte Carlo approach in this factor. And then we wanted to run thousands of simulations. So we had to automate the HECRAS. So we developed a series of a script using Python to have an automated HECRAS. So in this case, we could update the inputs, run the simulations, and we export the output at those flood marks locations. So we run thousands of simulations, and then we found those ones that in a reasonable range with the flood marks, which was what we consider plus minus 20 centimeter. The reason that we did that people actually sometimes that flood mark was just very close to the window, and they said, no, we put it a little bit above of that because they thought this is just doesn't look good. So we consider that uncertainty as well. And finally, we found a number of simulations that was match between the flood marks, major flood marks, and the major flood marks that we actually simulated. The initial idea, it was that this peak is about 100 cubic meter per second, and this is actually what is claiming by the authorities. But we figured out that this number is about 160 to 165, which has impacted on the basically whole that flood risk analysis, and also insurance of it could impact the insurance of those properties that could be impacted in the future. So this is more or less whole the project, but I think the one more point that I would like to just raise is that we had also a workshop, because some of the people from the event are still alive and they remember the event. So we had this workshop, and we used the input from the people also in this project to just, find more information about the event. But yeah, that's all. Thanks very much for, giving me this time. I had some technical issues at the beginning as well. I guess one of you guys helped me with this. So thanks very much.
Thank you very much, Ramtin, for the presentation, and to see how we go back in time, more or less. We have one more speaker here. It's Artem. He will, he or she, I don't know. I have not seen. We will have the presentation about modern water balance of the Caspian Sea potential disaster scenarios.
Yes, okay, I'm here.
Artem, here he is. Hello. The floor is yours.
So Greetings, everyone. My name is Artyom, and currently I'm a bachelor student of Moscow State University of Faculty of Geography. And today I'd like to talk about the Caspian Sea water balance and its problem. So let me say a few words. Why is it important to study water balance of the Caspian Sea? Well, it is especially important due to a main hydrological feature of this giant water body, and they are level fluctuations. Water level fluctuations that are about 4 meters over the entire history of instrumental observations. And such fluctuations cause an erosion of the shore, and the sea itself does not have permanent shoreline, what leads to struggles in economic sphere and in sustainable development of the regions, and even cause troubles in design and construction of all engineering structures, such as oil rigs and seaports. So the main scientific problem of the Caspian Sea is the long-term and ultra-long-term forecasting of its water level fluctuations. And in order to get those, we need to study properly modern water balance of the sea. And well, that is exactly what I've tried to complete in my research. What I've done is I've downloaded datasets from of several hydrological characteristics of water balance of the sea from 1950 to 2022. And they are total river runoff of the main rivers flowing into the Caspian Sea, such as Volga, Ural, Sefidrut, etc. I've downloaded this data from caspcom.com site. I've also used total precipitation and evaporation obtained from the ERA5 lens reanalysis from Copernicus, and also several more water balance things like total outflow to the Carabagaz Gold Bay, groundwater inflow and outflow, and etc. Well, then I've calculated statistical parameters of main hydrological characteristics. They are annual mean, skewness coefficient, coefficient of variation, standard deviation, and autocorrelation coefficient in order to use them for modeling and forecasting the Caspian Sea water level up to 2070. For that, I've used a special model that my supervisor gave me. It's called Aqua, and this model was developed at the Russian Academy of Sciences. And this program solves the differential equation of the water balance according to the obtained parameters that I've calculated and the future climate changes on the basis of Markov theory, and gives us future sea level fluctuations. So that is how I get artificial series of future water balance components. And then by using an analysis spatial equation, I've calculated water level regime and long-term forecasts of the Caspian Sea that you can see on figure 1. So with the rise of mean annual temperature caused by global warming, the model shows that the evaporation from the sea also increases and precipitation on the contrary decreases, which with the probability with 99% will cause the sea level to drop to critical marks of minus 33 meters by year 2070. However, on the stationary climate, excluding global effects, the sea level will also decrease and will fluctuate about around minus 29 or minus 30 meters by 2070 in average. Well, taking everything into account, under stationary climate, the Caspian Sea level would remain approximately the same as it is observed nowadays. For example, several days ago, it was around minus 29 meters above the sea level. And if evaporation would be increased due to the climatic changes, such as global warming, the sea level could fall down to minus 33 meters. And such scenario may have a disastrous effect not only on the changes of people's way of lives, but also may cause complete loss of functioning of port facilities and even may restructure the ecological system of the sea itself. Well, The last but not least, I've completed this research on April of this year, and the Caspian Sea water level was about minus 28 and 6 meters, and nowadays it's minus 29, as I said. So we can see we're going through the worst case scenario. That's all that I want to tell about Caspian Sea. Thank you for your attention.
Thank you very much for the very interesting insight. And wow, 33 meters, this is a lot. We need to discuss that further soon. But before we start to discuss, the question is Himeng here? No? Then I would say we will continue with the discussion. I'm pretty sure that, yeah. We see a shared screen. Do we need a shared screen? Björn, you wanna ask? Or is Himeng here? If not, then I would start a discussion, if that is fine with all of you.
We can start the discussion.
Yeah, Hemong is raised his hand, and I think a few minutes later he will be invited as the panelist. Maybe we can go to the discussion and then after.
Okay, then we will do that. Then I would say we start a discussion, and when we have seen a certain moment where the questions drop, then we will come back to the presentation. Would you give us the full screen of the attendees for the discussion meanwhile, please? So stop sharing, that we see the faces. Please, all in the auditory, turn on your cameras. Now I think it's the time where we will dig in deeper in the discussion. First of all, just maybe a short summary of the presentations, what we have seen. I said it in the beginning that our committee is quite large. That means we have a lot of people or a lot of members. And I think now you see also why this is necessary. So we discussed today about, or we heard about fluvial floods, we heard about storm floods, we heard about tsunamis. So we have a very huge variety of events what we can have. And we only talk about floods. We have not talked about droughts, even though we have heard today here in the presentations about it. So in the end, we really need to think about how the future climate will be, or how the scenario will be. And what I always find fascinating in this Young Professional Network Congress is that we gather from all over the world together. So we have seen presentations from Lima, from Mexico. We got some insight into Canada, until Milano. And the fun fact that this site is that Ali and I, our universities are just 50 kilometers away from each other. But here in this room, we gather the whole world. And I think this is exactly what we need. And this is exactly the reason for such a Congress and the success, because here we can share ideas, here we can develop knowledge, and we can exchange. And exactly this point we have reached now, the exchange in the presentations. So Ali, I would say we lean back, you and me, and we let you discuss. So do you have anything to add, to give a comment, to add something, or best thing, ask questions to the other presenters? It's for you, the Congress, so you should learn something, you should benefit from it. So ask the people what you want to know from their studies. So just raise your hand, turn on your camera, your microphone, and then let's start a nice discussion.
Yeah,
all people
course.
are.
Yeah, please.
No, go ahead.
Yeah, I think if nobody has any question, I can start, and maybe the participants will go ahead with the next question. Also, we have some questions in the Q&A part. Maybe one question addressing Piero. What's the main characteristics of the Seco River Basin? Its name has to do with its hydromorphology. If so, where does the supply come from to meet the demand? Piero,
Okay.
can you please?
Yes, can you hear me?
Yeah.
Yeah, okay. Thank you for the question. So to go straight to the point, is the Malanche Rio Seco Basin, the main characteristic is that it has a dry river. It has ephemeral conditions and hyper-arid conditions. what is the meaning of this? That it has to happen extreme event to reactive the flow, but it's not just water, it's hyper concentrated flow, mood flow. So there's no supply for this. There's no supply for this basin. It's a arid basin that when the flow is reactivate, it's not water, it's just it's hyper concentrated flow, it's mood flow, it's flash fluid. So I hope I answered your question.
Yeah, thank you. It was Juan Julio question. I asked you in the question and answers part. And also there are two more questions in that part, maybe, and another questions. And Stefan, if you want, also you can ask the question, the rest Artem, I think.
I would let you do that because
Okay, great.
I don't see them. That's the reason.
Okay, great. I can do it.
Maybe
No
you have a better
problem.
chat than I have.
No
Sorry.
problem. No problem. It's my pleasure. And Artem, the question asks, have you seen any complementary analysis incorporated to give the generated scenarios greater sensitivity in their variability than just having the average presented?
Well, thank you for your question. Actually, I've seen some works, and currently I'm working on such scenarios, and because right now I'm trying to use IPCC scenarios, but I haven't got any results yet. And well, what I'm trying to say right now is that Caspian seawater level highly depends on Volga, the Volga River total inflow. It's about 80%, 80 or 90% of total inflow to the Caspian Sea, and the sea level highly depends on this river. And right now we have a lot of dry years, and someday we won't have them, and the sea level would rise again. But now it's but under the stationary climate and under these conditions that I've used, the sea level would drop significantly to minus 33 meters above the sea level.
Okay, thank you. Yeah, Stefan, the floor is yours.
Thank you. So all the questions from question answer are answered.
Yeah, also there is a general question.
Yeah.
I think we should ask the question. Maybe you or other panel members have some responses to the question. The question says that based on the experience that has been accumulated through the use of hydrologic and hydraulic models, what's the current scenario in relation to the scenarios in the years in which the models were created, which allowed them to be tools for a disaster risk management process or water resources management? What's still missing? Yeah, this is the question. And I didn't get exactly the question. Maybe they are talking about the superiority of different methodologies over others, or which one is comprehensive. Yeah, maybe they are talking about this issue, but generally, in my personal viewpoint, we cannot say that, for example, one modeling approach is superior to others. All the modeling approach have some assumptions, advantages, disadvantages. And yeah, for example, we have some physical, numerical modeling approaches. Here also some guys presented HEC-RAS modeling approaches based on numerical resolution of shallow water equations. Some guys are talked about probabilistic modeling approaches. Each has their advantages, disadvantages, and in my personal viewpoint, no one can say that this model absolutely is the perfect one.
Exactly, I totally agree. You always need to see the boundary conditions, what you have, and then you select your model, what will give the results, what you need. But always keep in mind, every model is wrong. but some of them are helpful. And this is exactly what we need to keep in mind, that we have this uncertainty. And also today in some presentations, you have heard about uncertainties. That is always what you need to keep in mind. And I really liked it. Let me have a look at the presentation. I made some notes from Ramtin about the 1968 flood. So we were not there, and he talked about that the water level was in a range of 20 centimeters, which they said it fit well. And I think this is exactly what we need, because very often when we're doing flood disaster modeling, when we made flood inundation maps, then the mayor of the city is coming and says, oh, we have 3 centimeters more water than you have in the model. Your model is wrong. This is something where we really need to explain it to them, because they are not specialists. We need to tell them we have inaccuracy in the model, we have inaccuracies by the boundaries, and I think 3 centimeters is too much, and I think 20 centimeters, this is what I really liked in your presentation. This is something in a range where we say, okay, this is acceptable.
Yeah.
Something what we need to consider. But on the other hand side, when we think about range of water depth, Karina, I had to ask you already, in Acapulco, if I want to make holiday, how would you convince me that I go there? Are there any in Mexico? Just a general question. In Mexico, is this considered somehow about tsunamis? Do you have a tsunami warning system in such a case, or is there anything implemented?
Yes, yes, we have a tsunami observatory is a national observatory of tsunamis, and we have the first risk is earthquakes, and we introduce in civil protection program for by our disaster center in Mexico, and we have a program for observatory tsunamis for prevent and have a mitigation and adaptation measures for prevention for the population in general.
Okay, because you mentioned that you have an estimation time of 7 minutes until the tsunami reaches the beach where I'm on holiday. So
Yes.
this is a very short notice. So what would you assume? How much time do you need to start an alert for people to get evacuated?
Yes, yes, yeah. In fact, the National Center of Disaster has a alert system, but earthquake is I don't know if it's the correct word because my English is not so good, but
it's fine.
It's a early alert system with earthquake. It is implemented in the Guerrero coast, in the Guerrero coast, with earthquake when the earthquake occurs in the gap Guerrero. We have a early alert system that more or less give us 3-5 minutes more or less that for the alert, and this alert give us from a cellular for a mobile telephone in a message, and is the way that disaster center in Mexico give us the alert, the early alert, and we have 3 or 5 minutes. Then this time the arrival for the 7 minutes is for the lowest the lowest height that is a very short high tsunami. Is for this that is a very short time for 7. It's a very it's a very low high for the 8.5 8.2 meters more or less.
Okay.
The 24 minutes is for the largest height that we estimate with the model.
but I still think 24 minutes is a very, very short time.
Yes, it's very short because the epicenter of the earthquake that we estimate, we estimate in a depth to 100 more or less deep, and the distance is variable from the coast, but yes, it's a very short time, 24 minutes, but it's that we estimate with the model for earthquake with the COMCOT model, the Cornell multigrid couple model tsunami, and with the model with Manchina and Smiley for this location seismic model.
Thank you very much. It's
Thank you a
interesting
lot.
insights.
Yeah, it's very interesting. Yeah.
In this. May I maybe also continue with Rahul, because I was interested about your failure mode of your dam failure. So you said in your conclusions that it's of course always very varying how the bottom width of the breach is, or the breach at all. Did you perform different simulations for the breach to see how much time do you have to evacuate a city downstream of your dam?
Sir, actually, we have done 2D simulation as well as 1D simulation, and also the breach parameters. We have the breach progression. We have taken the sine wave during the simulation, as well as from the literature studies also we have considered. But when we are doing using the sine progression, I think the results are not I didn't got the accurate result, and because the sign progression is depending upon the dam parameters, like bottom elevation of the dam and the height of the dam. Depending upon these parameters, using this the sign progression will be occur in the HECRA. But as per the type of the dam, like for earthen dam, how the breach parameters will be varying, I think this case will be more accurate as compared with this case, in my view, sir. So that I have considered that points during the simulation, sir.
Okay, thank you. That is interesting also to see, to hear.
Thank you, sir. Thank you, sir.
And
are there other questions?
Yeah, I have a comment, a short comment to the participants. And for example, Ahmed talked about urban flood risk reduction. I just want to highlight a very simple and short question. I mean, when you are talking about flood risk, it means that you investigated hazard, vulnerability, and exposure components. Did you do such a research, or your study merely devoted to the hazard or susceptibility analysis?
No, like during my presentation, I said we have like divided the study. So vulnerability, hazard, and exposure. So the main concept was, like, when I initially started my PhD, we wanted to have like the flood maps from as I said, I'm working with the municipality of Milan over here. So we wanted them to give us the flood hazard maps. But now the problem with that was, like, they didn't have those maps. So we had to like shift towards doing the hazard analysis by ourselves as well. So overall, we need to incorporate the vulnerability as well. But for now, we have not done that. We're working on it. So it's a work in progress.
Yeah, and vulnerability, collecting vulnerability related data are very challenging.
Exactly.
Especially when you are dealing with health state vulnerability component. Do you have access to such data or no?
Not yet, but like we're currently thinking about using some functions. For example, for initial phases, we're thinking about simply using GRC function and see how it turns out. So if it doesn't turn out, we have this model developed by EU's called Inside Model for Vulnerability, if you've heard about it. We'll try with that and see the results. So we'll try like multiple models of the vulnerability and see how it turns out. If it doesn't work, then of course we'll need to turn towards the municipality and see what data they have and what kind of vulnerability we can incorporate with this study.
Okay, great. And Stefan, if you agree, I have a short question of Ramtin regarding the historical flood events and the reconstructed the maximum depths, if I'm not lying. Also, Ramtin, here in Germany, in July 2021, we experienced such an event. I prefer to call them extreme flooding events instead of historical flooding events because they exceed the maximum return period that we expected. So also here in Germany, the measurement devices and instruments fail to capture the maximum discharges during the flooding time. So we use remote sensing approaches to reconstruct the flooding. And one question is that how did you validate your results? You refer to the public knowledge, and you said that also we implemented such an approach. We used the crowdsourcing and the social media published data to validate our modeling approach here. And what was your methodology?
Yeah, in our case, the event that we were trying to reconstruct wasn't that old. So the event was 1968. So we had, as I mentioned, some people, put this plug in the buildings as the flood marks. So they just after the event, they had this plug in the just a structure of the buildings. So we used them and we measure them and we use them as the points that we wanted to validate our model. But there is one but here. So the challenges was the land cover and also the area was slightly changed, not dramatically. We were actually lucky in this case because it's one of those, cities that didn't change a lot, so they didn't develop the city in a like industrial way. So we were lucky about that. But for example, we had like a couple of bridges and a few roads that was it was established just after the event. So we validate the model based on 2024, and then we reconstruct the model that we had with that data we could find from the before the events, like from, for example, there wasn't a bridge, so we removed the bridge from the area. And then we apply all of these changes, and then we run thousands of simulations. So we had a large number of simulations, and then for each simulations, we try to match, those flood marks and also some of the pictures, some of the very interesting pictures that the people took from the event. So you could actually use for example, height of the people to see what is the water level is. So all of those things together were our validations points. And then we compare it against of those, 1,000 simulations that we got it from the Monte Carlo. And then we ended up to like, I don't know, probably 200 of the simulations were matched. And then we came up with this idea of that, minus 20 centimeter, as Stefan said, is just an acceptable range because you have a large number of uncertainty here. And out of those, we ended up that we are in the range about 150 to 170 cubic meters per second, which is, again, 50 cubic meter per second more than what the authority is claiming. So now actually we are in this stage that we're negotiating this with the authorities that these are our fundings, and then hopefully in the next release of the this data that is annual thing, hopefully they will update it. So this is something ongoing at the moment, but that was the main approach to validate the model.
Yeah, great. It was interesting. Also here, I saw some buildings they marked after flooding related to the 20, 30 years ago. It's interesting methodology. Thank you.
I think that's the methodology. And I have one more comment to Karina. So I'm actually coming from the field of expertise in tsunami. So, and it's all kind of related to Stephen's question that he asked. Yeah, you have 7 minutes, 8 minutes, and you're in the beach. Even if you receive one message, what was the reaction? It's funny to say that maybe the best solution is not running away from the beach, but going toward the sea. I don't know if you know this one or not, but the tsunami waves, when the wave breaks, that would be the problematic time. So if you manage to get a boat or maybe you swim toward the sea, you have a better chance to be survived if there is a mega tsunami coming. So that's one thing that you consider. You need to be brave enough to do that, but that could be a solution in like 7 minutes time that could do the job. But yeah.
That I never heard before, but I will take it with me to my next holiday. not only when I go to Acapulco, also somewhere else.
Yeah.
And let's see how brave I am, or let's say it in this way, hopefully we will never
You see,
experience
when
such.
when a tsunami wants to happen, you see always a drawback. So the waves that
Exactly.
coming toward the beach, it goes very, very back. It goes backward and it's just very, very. It's a not. It's something that you never seen, you know. Say, and then it goes back, and then you. That's also a good sign. It's not a good sign. It's a sign that you can detect there would be a tsunami. When it goes drawback, you will see a very large drawback, and then you have a few minutes, to be honest. And it's like we didn't manage to develop. I think the system that they have in Karina case is the system that they used to use in Japan, but now United States also come up with some sort of a solution that they have this buoyancy kind of a device in the ocean, so they can transmit the data slightly, in a shorter time. So that warning system could be slightly better, but again, we're in the range of hours. We're not in the range of days or yeah.
Good. Karina, if you have a short reply, I would give you the stage very short
Yes.
because we have one more presentation.
Yeah.
Yeah.
Only I got a clear that for example in Mexico there are education program with Marine Ministry with population with people, and this is when it occurs if the things of the things fall down for the floor, is a alert signal for the people go to the highest land, and it's a very short answer, but it's a signal when things that things fall down for the floor, people knows that they go to the highest land.
The highest
Thanks
altitude.
a lot. And another thing, quickly, that is this work was for the local tsunamis, no normal. It is a thing that I can see.
Thank you. I see tsunamis are really attracting everybody here in the auditory. So this is really interesting. But we have one more presentation. Himeng is here. He will talk about scouring process analysis of landslide dams, a case study of the Bake landslide dam break based on American model. I hope I pronounced it correctly, but we will hear it now from himself. The floor is yours.
Okay. Hello everyone, I'm Meng He. The topic of my presentation today is related to the process of landslide dam failures. The title is the sowing process analysis of landslide dams. We take the case study of the Bage dam break based on the numerical model. The sowing process of landslide dam failures greatly influence the downstream riverbed evolution and flood causing process, and influence downstream disaster mitigation decisions. However, current numerical models are less involved on this. So during the dam failure process, the set slopes of the inflow channel collapse and the bottom bed is thawed by the flood water, which lead to the large amount of sediment being mixed into the flood water, affecting the downstream riverbed evolution process and the flood disaster causing process. So the exciting prediction models deal with the set slope collapse process in the dam failures process in the simplified way, and do not involve the calculation of set slope soil collapse volume and the bottom bed soil volume. So this study combines the actual slope collapse process and aims to establish a numerical model of landscape dam failure that is more in line with the actual situation. So the methods we divided the sawing process of the dam body into two parts. One is the set slope collapse, and the second is the bottom bed sawing of the division channel. So when calculating the set slope collapse process, the figure 1, the critical depth is used to determine whether the set slope is collapsing or not. When the set slopes collapse, cyclic calculation is performed to determine the collapse soil volume using the collapse schema. Another part is the calculation method of the soil volume of the bottom bed of the diversion channel. So we take the Berger steam dams as the study case. The conclusion is the flood peak flow calculated by this model is 650 cubic meters, which is close to the actual wall value. And the soil volume relative error is 8.5%. So the result shows that the calculation or accuracy of this model is satisfactory. That's all my presentation. Thank you.
Thank you very much for the presentation. So we have seen another diverse topic in this session, which I think it's really nice to get the overview. But maybe I can start directly with a question. When I compare the numbers what you have presented, like the volume of the soil with about 4 million cubic meter is much more than the soil than the water, the big discharge with 31,000 cubic meter. So does the sandslide have such a huge volume compared to the small water?
This we take the 31,650 is the flood peak flow, and another number is the soil volume. It's it's 2 cents, yes.
Okay, but it means you have a huge sandslide in this case, what you simulated, and I also think then this 8% error is not that much. But maybe somebody else has also a comment. So I open the floor again for questions to all, not only to He. So just please go ahead.
Okay.
And there is a question in the Q&A part. They addressed Ming. I think they asked, could you consider other possible failures such as overtopping, etc.?
In fact, we just take the Berger landscape dam as one case. Other case is not simulated because the landscape dams have a lot of conditions. We just and it has less data to validate. So we just we have the Berger landscape dam have the data. So we just take the this as a one case, and others is not.
Okay, thank you. And I have a short question. Which numerical model or which numerical scheme did you follow to resolve the question, the dominant equations?
We take the two-dimensional models, use Fortran language. We use water equation or water volume equation equations and another such as soil equations and others. So we established this model. Use these methods.
Thank you. Great.
Okay.
Yeah, other questions?
I had one question to Isa, but I think I have not seen him.
Yeah, me too. Isa, are you here? I think he left, maybe.
Okay, then maybe I continue. I have one more question to Artem about the Caspian Sea again, because what I'm thinking about is when you made your simulations, then you showed with climate change, you have a drop of about 33 meter, and without the climate change, you have 29 to 30 meters. So that in the end, it's like you're losing, your altitude will be lowered so what do you think is climate change here not that drastically like in other places in the world, or what could be the reason for this minor difference?
Thank you for your question. Well, it's quite hard for me to say what the answer is, but I think that the sea itself is strongly corresponds to the total inflow and precipitation and evaporation. And with the increase of evaporation due to climate change and decreases of precipitation, it would highly drop to minus 32 meters above the sea level. And it would happen until the total inflow would increase. So nowadays in Russia, we have like dry years when we have less precipitation in the winter that accumulates like in the snow, and then the snow flows into the rivers. So we don't have much precipitation, but I think that in 1 year or two we would have we won't have a dry year. We would have a flooding year, and the sea level would increase, but not so significant because the evaporation is also already increased a lot.
Okay, because I was also wondering, have you calculated the area? How much it
Yes.
will shrink?
Well, there is a special book that I used in my study, and it has an equation between the surface area and the water level that is calculated through on the main hydrological posts, like in Makhachkala and Baku in Azerbaijan, and it measures the annual sea level, and yeah, this is an equation that correspond to the surface of the sea.
Very interesting to see like what we experience in the future. It's not only floods, we also need to think about droughts and of course the changes, because 1 year we have a wet year, as you said, and 1 year we have a dry year. So we experience now in Germany at the River Rhine, for instance, this very dry years where we stop our vessels. Meanwhile, we are shut off nuclear power plants because we don't have enough water to cool them down. And at the same time, in winter, our locks are frozen and we cannot have any ships there anymore. So we're really experiencing now a very harsh time. And I think we all are there, or this is our community where we want to work on. So the time is almost over. So it was a very interesting discussion with all of you. And you see there are many, many questions. What we could continue like that for many hours, I would say. Ali, what do you think?
Yeah, that was very interesting presentations. And I think, as you told, also due to climate change, we have to think about multi-hazard analysis instead of just flooding. Maybe we can think about flood, drought, they are interconnected to each other. The presentations were very good. I enjoyed, I learned a lot. Yeah, and if there no question in QA part, so we can close the session if you want.
I agree. Thank you very much, first of all, to all of you for the speakers, because I think you are you're the salt and the pepper in such a session, because such sessions can be very boring, but I think with such interesting presentations, they will never be boring. And also thank you all for the discussion. Thank you for Ali, also for being the co-chair or the second chair of this session. And also thank you very much for the hosts for hosting us for all the technical issues, because we didn't have any technical issues. So this was very well performed. Thank you all. And then have a nice next session. I think it's about water management. Water management fits for everything. The next one is water resources management, of course, with otherwise or afterwards with the mentors. And we stay in touch. If you have questions, please write me or write Ali, or also write in to each other. So this is something where you benefit. Always keep in mind for your future career, networks are very, very important. Of course, it's also important to do good research and cutting edge research, but also networks are very important, because we are here to support each other, independent where we're coming from, what we are doing. I think this is the most important thing. And with this, I would like to end the session today. Thank you for joining.
Thank you, Al. Thank you,
Yeah,
Stefan.
thanks very much, everyone. Yeah,
Thank
bye.
you.
Thank you.
Thank
Bye.
you, Stephen.
Bye.
Thank you,
Bye.
Ali, for
Bye-bye.
chairing this session.
Bye,
Thank
everyone.
you,
Thank
all
you,
the
Al.
presenters.
Hello.
Thank you, Kian. So now for our next session, water resources management. So all the presenters, please raise your hand so I can promote you as the panelist. So now Eva and Jose, I think they have also joined. Welcome, Eva. So now over to you.
Thank you. So as Manish just said, if you're a speaker in the session and you haven't raised your hand, please do so we can let you in. And we'll start in about a minute.
I'm trying to identify the background. How do I get that background? I have it on my computer.
Click on the video, you have a small arrow or a small, let's say, apex symbol. And I think you can choose the second, you have something on the background, then you have something on effects. When you choose that one about effects, you have virtual backgrounds as the second possible thing to choose.
Yes, so I have virtual backgrounds. So
You have like nonce, foca, and I think you have a plus, and there you can add a picture.
Let me see. Okay, I'm just trying to find one here.
Our second mentor is just joining.
In general. Sure. Fabric defects. Okay.
So now, as we're getting ready for this session on water resources management, a very warm welcome from us, from the organizing committee. And this session has also two mentors that are going to chair this session, Ramesh Tigavaranthu and John Okedi. And I'm really happy that they're going to support you and chair this session and lead the discussion in the coffee break. Over to you.
Okay, so is Ramesh here? I think you're muted. Ramesh, if you're speaking.
Yes. Can you hear
Okay.
me? Huh?
Yeah,
Okay,
yeah.
thank
So
you.
you're the lead chair. I'll be your co-chair then.
Okay, thank you.
Yeah.
So I guess we have, I don't know how many presentations we have. We have around, at least the listed ones are 12.
Yeah.
But I'm not sure if everybody's here.
Yeah, maybe to find out. So
Yes,
maybe the
yes,
host can help us. How many of the presenters are here?
Okay, so I guess we have to probably start the session for the sake of time, and then.
Yes, please start the session.
Okay, thank you all for joining this session on water resources management. This is a very important topic for us for the conference as well, because water resources management comprises of all subtopics within hydrology, hydraulics, and other sister disciplines. We try to tackle problems related to water resources using a number of techniques, both hydrological modeling, hydraulic modeling, and the intersection of other disciplines. So today we have, in this particular Congress, we have, at least in this session, we have 12 presenters available, and we have a total of 90 minutes, including the coffee break. So we would like to start the session and then give around 6 minutes for each presenter so that we can have some question and answer session later on in the coffee break. Or we compile the questions as we go on. Audience can ask the questions, put it in the chat room, and then we can address them after the session is over. So if the first presenter is here, we can request them to start. This is about microplastic distribution in estuaries during pre-monsoon period. So after you, Hari Krishna, I guess. Who's presenting this particular paper? The first.
Does not seem to be around. So maybe hosts, because I see you've displayed their poster. Maybe if they're not around, maybe you can go to the next one.
Let's go to the next one.
Okay. So maybe I should introduce the next one. So the next poster is on an experimental evaluation of photo degradation of cage nets under different environmental conditions. And the poster is coming up shortly. All right. And then if the presenter is around, they can proceed to do their presentation. 6 minutes.
Good evening, sir. I'm Hannah and George. I am a civil engineering undergraduate studying in TKM Engineering College under APJ Abdul Kalam Technological University. Today, I'm going to present our work and experimental evaluation of photo degradation of cage nets under different environmental conditions. First of all, I would like to introduce the term cage farming. It is a method used for cultivating fish in a confined habitat, used to contain and protect the organisms, allow the water flow, and prevent escape and predation. So for this cage farming, the commonly used cage nets are synthetic nets, which are nylon, polyester, and HTP, that is high-density polyethylene. And when these nets are exposed to different environmental conditions like sunlight, UV, pH, and turbulence, they degrade easily, and it causes microplastic pollution. So the microplastics are the particles which have sizes under less than 5 mm. And when they are exposed to, when it leads to microplastic pollution, it actually affects the aquatic species and also the human health too. So our study actually examined the rate of degradation of these different cage nets under different environmental conditions. And the laboratory test like gravimetric analysis is used for evaluating the rate of degradation. So moving on to the methodology, the materials we used were the synthetic net, that is nylon, HDPE, and polyester. These nets were separated and each sample have a weight of 100 to 500 milligram each. And they were exposed to UV and sunlight conditions under 0 gram per liter and 10 gram per liter salinity conditions for a period of 12 months. And these were analyzed with percentage weight loss under each exposure condition. And we evaluated the rate of degradation through this weight loss. Moving on to the result section, I would like to explain this through the graph. So the first graph is representing the cumulative percentage weight loss of the net under 0 gram per liter salinity condition. And the second graph is representing the cumulative percentage weight loss of net under 10 gram per liter salinity condition. So in this graph, the dark blue and the orange line is representing the nylon under UV and sunlight condition. The gray and the yellow line is representing polyester under UV and sunlight condition under the exposure of UV and sunlight. And the light blue and the green is representing the HTP nets under UV and sunlight exposures. These are the same color patterns for the second graph too. And coming on to the 0 gram per liter salinity level graph, for the first 3 months, there is no significant weight loss is showing. And after that, there is a significant increase in the weight loss can be seen. And that is the degradation rate is getting increased. And after the 12th month, it becomes constant. And for the second graph, we can see that even for the 10 gram per liter salinity level graph, we can see that even from the first month itself, there is increase in the weight loss. And it actually remained constant after the 12th month. So overall, we can say that the 0 gram per liter salinity condition, the degradation rate is slower than the 10 gram per liter salinity levels. So coming on to the conclusions, the aquaculture activities using the synthetic cage nets contributes to microplastic pollution, especially from nylon. And the laboratory tests like gravimetric analysis reveal that nylon is showing higher degradation rate and it degrades very quickly. And the HDP and the polyester nets, they exhibit greater durability. And the HDP is showing the lowest degradation rate. So it can be taken as a resilient option. So overall, I want to conclude that among the synthetic nets, HDP can be the preferred material for the cage net in aquaculture due to its long-term durability. And thank you, sir.
Thank you.
Okay. All right, thank you very much. You spent only 4 minutes, 4.5 minutes, so that's great. I'll hand over to Ramesh to introduce the next presenter.
Thank you. The next presentation deals with climate change impact on precipitation patterns. This is in the multi-model analysis in Ottawa, Canada. So this seems to be a very interesting presentation. The past one was also very nice and precise. So is the presenter here? Any one of the presenters from this poster? Okay. They are not here for some reason. Okay.
Okay,
So I guess
so let's move on to the next one.
Yeah. Please go ahead and introduce. Okay, the next presentation is about chemical coagulation for freshwater treatment with reference to microplastics again. So anybody for this poster available for presentation? Interesting. We missed quite a few presentation speakers today. Okay, maybe they might join.
Okay.
Okay,
Maybe
let's move to the next one, and we can go back by the very end to see if they
if they join. If they join
Yeah,
later, we can help them to present.
Sometimes they might have problems with the connection or whatever.
Connectivity as
Yeah.
well.
Okay.
You can introduce the next presenter.
All right. So the next one is on citizen science in Versailles, Villar, data mapping and community, and just Sachin Mati. Could they be around?
Hi, I am the co-author. Unfortunately, Sachin is here, but his network is quite bad, so I'll just be doing the presentation. And
Okay.
if there are any questions, one of us will try to answer them.
Okay. Good.
Okay.
Could I start?
Yes, you can
Yes.
start.
Okay.
Yep.
Okay. Hi, everyone. It's great to be here today, and I'd like to thank the organizers for giving us the opportunity to present our work on knowledge generation and what we could call do-it-yourself citizen science and water activism. We hope that this presentation underscores the potential of participatory water management as well as limitations of initiatives which are ground level. So our field site, which is also Sachin's residence and mine as well, is along the western coast of India and very close to Mumbai. In the 90s, just to give you a background, there was a social movement which emerged from the cluster of villages centering around groundwater conservation and limiting unchecked urbanization. However, when Sachin started his work in 2011, it was a very different situation. Social economic changes had happened within the community and the villages. The relationship between land and water and the community had changed. Additionally, when we started talking about things like water bodies and conservation, we knew close to nothing about like concepts of hydrogeology, data collection methods, or the equipment needed to carry out any meaningful studies. This is where the method section becomes relevant, which you can see on the poster. Even though it's presented as a list, over the last almost 15 years, it's been an extremely iterative process. Our colleagues have continually self-trained and upskilled. This includes accessing open literature, attending workshops, classes, as well as connecting with subject experts who would sort of guide the process of collecting data, mapping water bodies, as well as like what to do with it in terms of once the data has been collected. And the inputs of these experts has been critical and remains critical in shaping and refining the study methodology. Because of the limited time, I won't go into details about the results. You can see them on the screen. What we can say is that since 2011, we managed to do a fair bit of mapping, surveying, identifying, and knowledge disseminating, both within and outside the community. What I do want to share with you today are three takeaways from like doing this over a decade and a half. First, resource constraints are very real and they shape many of our priorities. This includes the kind of surveys we can do, the testing equipment that we have access to, and the time that we and other volunteers within the community and outside can devote to such an exercise. This creates a very interesting tension in making this surveying and monitoring a regular recurring process that should happen every year or a couple of years rather than a one-time event. And our efforts have been to make sure that it happens and even expands in scope. Secondly, for any ground level initiative to succeed, it is crucial to build networks both from inside and outside the community. We have personally seen the effects of building coalitions within the community and its role in bringing people together to present our findings. At the same time, none of this could have been possible without a thriving network of individuals and institutions who have continually provided us guidance and support. And finally, and this probably is probably the most important, is that local context and history matters. Uh, Based on our own experience, the local context truly defines how a community engages with the environment and the amount of time and effort required to build a consensus around the idea of preserving or conserving or restoring traditional water bodies. In over a decade and a half of working within the community, it has been a very slow process to bring people on board, trying to convince them that it's important to conserve, restore, and monitor it regularly. Local history also shapes how we engage with the community and the kind of language and the signs and the colloquialisms that we have to use to get the points across, as opposed to when presentations are being done, say outside at a conference or a platform like this. Uh, we hope that this work contributes to our understanding of the possibilities, limitations, and the need for ground level citizen scientists in communities across the world. Thank you.
Okay. Thank you very much. Right in time as well, 4 minutes. And in fact, since we finished before the 6 minutes, I'm kind of tempted to ask for a question, but since they're all coming to the chats, I'll append those to the coffee break, and then I'll hand over to Ramesh to introduce the next presenter.
Sure. The next presenter talks about diurnal propagation and characterization of drought in upper Rimac system in Peru.
Hello, good afternoon. Can you hear me?
Yes,
Yeah.
yes.
Please go
Thank
ahead.
you. So can I begin?
Yeah.
Well, good afternoon to everyone. I am Andres Figueroa from Peru. Today in this session, I would like to present a research that I did with a team of Citautec from Peru and researchers from Project Perfect Storm of U Amsterdam. This research is titled Propagation and Characterization of Drought in the Upper Rimac System, Peru. Well, to begin, water scarcity is a big issue in Peru, a country of Latin America, especially in Lima, which depends on the Upper Rimac Basin reservoirs. Droughts in the Upper Basin can severely impact water supply, and this problem will become more complex in future. By this reason, this research focuses on characterization of these droughts and fine understanding of their propagation between reservoirs and hydrometric stations. The study area, as we can see here, is a part of the complex hydraulic system of Rimac. Here there are 15 reservoirs and 2 hydrometric stations. About the hydrometric station, one is called Milok, around the reservoirs in upstream, another called Autisha in downstream. We divide the reservoirs for an easy analysis between 3 groups. This division was done by the precipitation regime. In this study, we will analyze the case of group 2, located in the center edge of this hydraulic system. As we can see here, is in the green circle, and these reservoirs have a capacity of 41.558 m3. In methodology fields, we use 3 types of data sets: monthly precipitation, monthly water level, monthly water volume. We, with these variables, calculate standardized indices. Also, with this standardized indices, we use a new method called drought cycle analysis. With this calculation, we do the characterization and analysis of the drought's propagation from precipitation to water storage. This study, we apply a new innovative method for analysis of drought called drought cycle analysis. This is a classification method for drought events using a combination of precipitation and hydrological indexes. As we can see here, there are a well with 4 quadrants. There are 3 quadrants of droughts and 1 scenario for wet. This is divided by 2 axes. The y-axis is dominated by precipitation index, and the x-axis is by water scarcity indices. that could be an hydrological variable like water volume of reservoir for stream flow or water level of hydrometric station. Here exists four quadrants. A blue quadrant that is the wet quadrant with normal condition in precipitation and water storage. A yellow quadrant that exists a deficit of precipitation, normal condition of water storage. A red quadrant that exists a deficit of precipitation, water storage. And finally, a brown quadrant that exists normal condition of precipitation but water storage deficit. Well, about the results, in few words, severe droughts occurred in 1990, 1992, and 2004. Also, the lower part of the basin experienced more frequent but shorter droughts, while the upper basin faces fewer but longer lasting droughts. About the rest of drought cycle analysis, here we can see, for example, two kind of analysis, two graphs, the drought cycle analysis of the reservoirs and the drought cycle analysis of the water station. Here for reservoir located in the central east part of the basin, about this analysis, the reservoir, I am comparing these two the drought cycle analysis. For reservoir located in the center east part of the basin, the onset of hydrological droughts was delayed by approximately 2 years compared to the initial drought signals observed at the hydrological station during the 1994 and 1996, as we can see here in plus wet condition. This delay can be attributed to the proximity of the Amazon basin and the influence of hydraulic diversion. In the years that followed this event, 1994 to 1996, the propagation from hydrological to hydrometeorological droughts was notably slower and weaker. Additionally, while the period from 2000 to 2004 was characterized as wet in hydrometric station drought condition, in the reservoirs persisted until 2002, reflecting the lag in recovery within reservoir system. Another analysis, for example, in this comparison, from 2012 to 2017, the region experienced sustainable dry condition. In conclusion, well, the DCA, in few words, effectively distinguished the propagation of drought from meteorological to hydrological scales, highlighting variation in drought impacts across different location and hydrological variables. Also, the reservoirs can mitigate drought impacting by storage water, but may worsen conditions when reserves are low or management is poor. The proposed drought propagation approach of this focus highlight complex interaction between reservoir operation and drought impacts, providing valuable insights for developing adaptive water management strategies. Well, this is all. Thank you.
Thank you. We have the next person available.
Okay, maybe you can give us can share the poster.
Yes, give me a second, please. Okay.
Yeah.
Okay. I'm introducing this one.
Yeah, go ahead.
Okay, so our next presenter is presenting the poster is on diurnal fluctuations of dissolved oxygen in lakes with different trophic states. And the author there is Seyon Polkin. Are they around?
Yeah, good evening from already snowy Moscow.
You have 6 minutes. Go ahead.
Yeah, okay.
Please.
I'm final year student of Department of Land Hydrology of Lomonosov Moscow State University. So, dissolved oxygen is essential for all aerobic aquatic life. Oxygen deficiency is in a water body can lead to the death of these life forms, affecting chemical and biological processes. Therefore, dissolved oxygen concentration is commonly used as a key indicator of aquatic health, and estimation of changes can provide helpful information for management of aquatic system, especially in relation to the problem of eutrophication. The purpose of my work is to identify patterns and characterize short period fluctuation of dissolved oxygen in lakes with different trophic states. The study considers two Russian water bodies located in the Moscow region, eutrophic Можайское Reservoir, which plays a key role in the water supply system of Moscow, and mesotrophic Lake Glubokaya, which is a water body with a little anthropogenic disturbance. As initial data, we use data from automatic loggers of oxygen concentration installed during ice-free period of years 2020 to 2023 at 0.5 meters depth with a recording interval of 10 minutes. The study revealed average characteristic patterns of daily fluctuations of dissolved oxygen concentration in the surface layer of studies water bodies. Now, let us consider the most remarkable months, May and September. In Figure 1, you can see that in May, the average daily range of concentration fluctuations was small and amounted to 5.7% of saturation for the reservoir and 4.7% of saturation for the lake. The small range of fluctuation can be attributed to the low intensity of destruction processes due to relatively low water temperatures. Now let us discuss the pattern in September. The highest values of dissolved oxygen concentration were observed in Lake Glubokaya, while the average daily range reached maximum values in Можайское Reservoir. Also, in September, it can be noticed that concentration during a typical day on the month were higher in Lake Glubokaya. This may be due to higher rates of destruction of organic matter forming during summer, which is more abundant in the reservoir than in the lake due to higher trophicity. On the other hand, the lower absolute oxygen content may be related to the gradual deepening of the thermocline up to the complete destruction of density stratification, as a result of which the anoxic water mass mixes with the oxygen-rich waters of the epilimium. So, summarizing the result, the range of fluctuation of oxygen concentration in Можайское Reservoir during the entire vegetation period was larger than in Glubokaya Lake. The maximum range of intraday variability of the content was observed in August, the minimum in May. The concentration range varied during the day due to development or death of phytoplankton communities, destruction of strengthening of temperature stratification, and formation of run-up and surge events. So it was revealed that at higher trophicity of the lake, greater fluctuation in dissolved oxygen content are detected. That's all. Thank you for your attention.
Okay.
Thank you so much.
Thank you very much. Over to you, Ramesh.
Yeah. Let's wait for the next presentation. This will be on the effect of chemical composition on the reverse osmosis filtration. Is the presenter here?
Yeah, I'm
Okay.
here.
Thank you.
Okay, thank you for your presentation. I am Ernesto Ramirez from the University of Zacatecas, Mexico. I'm going to present the effect of calcium-magnesium ratio on the reverse osmosis filtration. It's important to mention that reverse osmosis is an efficient treatment process for the purification of drinking water. However, this has a problem, and the problem is the scaling. This problem limits the performance of membrane filtration process. The scale is the most principal components of the scale is calcium carbonate, sulfate carbonate, and silica. Exists some recommendation to reduce the scaling in membrane filtration process. Some of them are not to excel in the solubility products, no combination of scale formation species, and water pretreatment. And the most common approach to prevent scaling is the pH adjustment and the use of scale inhibitors. However, in some previous experiments, we observed that the calcium magnesium ratio could prevent the calcium precipitation, This we observed that when we have low values of calcium magnesium ratio, we can prevent the calcium precipitation. And for values higher than 2, we observe a precipitation of calcium. This is because magnesium could be an inhibitor of calcium precipitation. However, this calcium magnesium ratio has not been studied in a membrane filtration process with the aim to reduce the hardness of water. For this reason, we study two calcium magnesium ratio to compare the effect in the membrane module, which consists in a tank, in a feed tank. This tank feeds to the membrane module, and the membrane module produces 2 lines, the perma line and the concentrate line. These 2 lines are mixed, and then these just keep in the water in circulation. Also, we determine the calcium concentration in the 2 lines during the time of filtration, and we observed that exists some difference between 2 experiments. For example, for the calcium magnesium ratio of 1.1, we observed that the calcium maintains its concentration for the concentrate line and for the mixture line. This means that the calcium are not precipitating. However, for the calcium magnesium ratio of 4, we observe some precipitation of calcium, nearly 10 milligrams per liter for the 50 hours of experimentation. This is consistent with the previously studied, in which for batch sites, we observe that calcium magnesium ratio is very important to reduce calcium precipitation. In this experiment, we observe that the ratio of 1.1 produce a metastable solution that prevent or avoid the calcium precipitation. However, for calcium magnesium ratio higher to values of 2, 4, or even 11, we observe a high precipitation of calcium. As conclusion, we can mention that this could be a parameter to be considered, the calcium magnesium ratio, to prevent the scaling in membrane modules. Also, we study different, we can study the use of magnesium as inhibitors of the formation of the scaling in these membrane module processes. Thank you so much.
Thank you. Okay, we can go with the next presenter.
Okay, so the next presentation is on integrated approaches for sustainable soil and water management in the context of climate change. And the presenter, at least the main author here, is Subhasri. They're around.
Looks like they are.
Like it's not there. Yeah, but maybe just to mention that for the previous presenters, if some of them have arrived, you can put up your hand so that the hosts can note that you've arrived. So we shall come back to this this list at the end when we get to the last person. But as soon as you join the session, just put up your hand and the host will note that you're around, and then we shall come back to you when we finished the entire list. Maybe put the next one, the next presentation. So this presentation is on modeling of water and thermal regime of urban lakes. And the presenter here is Christina.
Good evening, everyone. I'm a student of final year at the Land of Hydrology department in Moscow State University. So I'd like to start with that urban lakes are natural bodies of water located within the cities, and they're often small in area and shallow in depth. And nowadays, such lakes are the most vulnerable due to urban development and global climate change. For example, urban heat island, impervious surfaces, collector drainage network, changes in precipitation and evaporation regimes affect the water and thermal regime, and thus the ecological condition of urban lakes. The purpose of this work is to model features of water and thermal regime of Kasinski lakes in modern climatic and landscape condition, and they're located in Moscow. And the object of the study are two contrasting lakes, the deep Belaya Lake and the shallow Svitoy Lake. The data of temperature loggers are monthly. The data of temperature was obtained with the loggers and monthly observation from 2021 to 2023, and the meteorological data from reanalysis were used for this research. The one-dimensional general lake model was released in 2012 and continues to be updated and is used worldwide. And it was successfully adapted for two lakes. For Belaya Lake's root mean square error is 0.33 degrees Celsius, and for Svitoy Lake, this error is 1.3 degrees Celsius. And according to the analysis of key components of water balance, July, August, and September were both the rainiest and the driest in some years, and evaporation is maximum in summer and minimum in winter, which is generally natural. Also, water level was obtained with the help of modeling, although due to high rate of urbanization and lack of data on underground outflow, it has a difference with the real situation after the period of time when construction has started on the watershed, and because model can calculate these changes. Moving on, the water surface temperature varied from 0 to 33 degrees Celsius for both lakes, as you can see in the figure 2. And in the bottom layer of the Miktik Belaya Lake, it ranged from 1 to 9 degrees Celsius, and the thermocline depth was at 11 meters from May to October. In the polymictic Svitoy Lake, from April to August, the thermocline depth was almost 2 meters, or wasn't observed at all due to mixing. In the summer, cases of stratification break increased by 2033. To see how urbanization affect water bodies, these lakes were compared with Lake Glubokie, which is located in the weakly urbanized area in Moscow region. And evaporation from Belaya Lake is 2 times more, and from Svitoy Lakes is half times more intensive than from Glubokie Lake, even though the area of their water surface is less, as you can see in figure 1. Urban lakes also open for 10 to 12 days and heat up to 4 degrees Celsius for almost 2 weeks earlier. Also, stratification forms 2 weeks earlier, but breaks for 3 to 6 days later. And maximum water temperature may be by 2 degrees higher in urban lakes and occurred 2 weeks earlier. So, summarizing the result, general lake model has been successfully adapted for these lakes. And based on the result of modeling calculation, thermal regime is described. And compared with the background condition, the Kasinski lakes open and warm up earlier and cool down and freeze later. And in conclusion, this work is the first step, which can be a basis for further improvement of the adapted model. And eventually the model may become an effective tool for diagnostic and prognostic assessments of the hydroecological regime of urban lakes condition, of urban lakes condition. And that's all. Thank you for your attention.
Thank you.
Thank you very much. Under 6 minutes, so well done. Over to you, Ramesh.
The final, at least the next presentation, is on spatio-temporal assessment of projected reference evapotranspiration under climate change. Do you have anybody presenting this paper?
Hello, everybody. Do you hear me?
Yeah.
Yes. Yes, we can hear you.
Hi, everybody. My name is Fatima. I'm a PhD student at the Polytechnic University of Madrid, where I'm focused on studying the impact of climate change on water footprint and agricultural products.